Good morning, everybody. Good morning, everybody. Just want to know you can hear me, can see the screen. Just checking. Hello.
Yes, sir.
All right, cool. All right, so basically just continuing what we started yesterday, which is to go through this large bank of ADMATS questions. Right, we did a number of topics yesterday. These are arranged by topic. And as I said yesterday, I believe, well, I know that, once you understand all the questions in this document that we're going through, you will have an extremely easy time in the exam on Wednesday, as there are not many different ways that these questions can be set. Right? So this basically we're covering all the various ways that they are likely to set these questions, the multiple choice questions. All right. So we did a number of topics yesterday. I'm going to start right away. But it is that I want to basically finish off the topics that we did not do yesterday. There's one question that we did yesterday that I want us to revisit, though. As I was thinking about it since yesterday, that I felt as if it was too much work to get it, and there must have been an easier way. And I thought about it. This question here, I think it was the very first question that we did actually. So we did it as if we were doing a paper 2 question. This one right here. Let me get the pen. This one right here. All right. So we did get the correct answer, but I feel as if we did too much work. So I'm going to erase it and do it another way, which I know is much easier, because those are my mind from yesterday actually. So let's do it another way. And the reason it can be done this way is because what we're really having here are 3 consecutive values. It says we have a GP, it's a geometric progression. It says each term is positive. It tells us the 5th term, it tells us the 7th term, and the term between them, which is a 6th term. So there are 3 consecutive terms of a GP now. So if I call the 6th term X, for example, let's call it X, then the terms would be 45, X, and 5. 3 consecutive terms of a GP. I know a GP has a common ratio. What it means is that the X divided by the 45 is equal to the 5 divided by the X. And that would be the common ratio. And that's the approach. It's a much easier approach. So the common ratio R would be equal to X divided by 45, but also be equal to 5 divided by X. And we're really doing the mathematics here. We're doing the mathematics right here. So we're solving for X there. But let me zoom this up and write a little bit smaller. Let me just zoom it up and write it smaller. All right. So we're trying to find the R. No, we're not trying to find R. We're trying to find the X, which is the 6th term. So the X is our 6th term that we're trying to find. So let me mark that. This X is our 6th term. So find X, we'll find the 6th term. So basically solving this equation right here. So we can cross multiply. So multiply this X over here. Multiply this 45 over here. So we end up with X squared equals 5 times 45. And so X is the square root of this. All right? Now the 5 times 45 is the same as 5 times 5 times 9. Because the 45 is 5 times 9. And so it becomes easy now. When we square root, X becomes equal to the square root of this. So it becomes the square root of the 5 times 5 is 25 times the 9. I mean, we could work it out with the calculator. 25 is a 5 times 5 times the 9. And so it becomes the square root of the 5 is 25 is 5. And square root of the 9 is 3, which becomes 15. And so we get the same answer, 15. But I think this is a much easier way to do it. Simply because they gave us 3 consecutive terms of the GP. So this basically was a GP. 3 consecutive terms of a GP. That's what that is. That's a GP right there. And this is the 5th term. We mark it. This is the 5th term, the 6th term, and the 7th term. We mark it like this. So this one is the 5th term. That's the 6th that we don't know. And this one is the 7th term. So there are 3 consecutive terms. And so we can establish the common ratio is a term divided by its preceding term. And so this ratio is equal to this ratio. And then we'll solve for the x, which is our 6th term. And that's it. All right, so I just wanted to revisit that question. And you know, it's always good to do the mathematics the easy way. All right. So let me go back up to where we were now. So let me see where we're at. I think we're just gonna maybe work straight today, right? Let's work straight. I'll try to finish it as quickly as possible. I know a lot of people have physics and chemistry coming up and biology. So it's not all about just add maths. So, you know. All right. So we had gotten through these first couple pages, polynomials and quadratics. We had gotten through those yesterday. And then we came up to functions, but function is no longer on the paper 2. All right. So I'm skipping over the function. Function is no longer in the syllabus generally. So I'm skipping over that. I'm skipping over the functions. Remember, this was compiled from years of compilation. So it was compiled when functions was still on the syllabus. So we're going to go into the indices. So we're going to go into surds, logs, and indices. Surds, logs, and indices. And this is the first one, number 12. All right, so starting at number 12. So let me zoom that up. So this question wants us to write this in another form, which is one of these. So these are the laws of indices. Now, these can be written as base 3. This is root n, and this is raised to the power n. So I'm going to basically rewrite this. I'm going to rewrite this. We're trying to express it as 3 to something based on this, right? Well, this one is out of it, but let's go. So the root n can be written as a power of 1 over m, 1 over n. Inside here, I'm going to write 3 times, this 27 is 3 cubed. So it's 3 to the 3m. That becomes, you know, this thing becomes 3 to the 3m because the 27 is 3 cubed. And all of this now is raised to the power of 1 over n because the root is n, then the power is 1 over n. 1 over n like that. And then here now, because these are the same base, this really has a power of 1 on it. This has a power of 1 on it. And so we multiply numbers with the same base, you add the powers. So inside here now would become 3 to the 1 plus 3m. And you're raising that to 1 over n. And then you can also multiply these now. So if you multiply those, you're going to get 3 to the 1 plus 3m over n. So this becomes a power. Let me write that better. 1 plus 3m over n if I multiply these using laws of logs. And this answer is actually right here. Just that the spin around, switch around the m and the n with the same answer. So the answer is right here. Mark it in red or something. First one. And let me make a note up here that the 27 to the m is same as 3 cubed to the m. And then multiply these, it becomes 3 to the 3m. And that's how we get that 3 to the 3m down here. Let's just make a note of that, all right? That's how we get that expression for the 20. Anyway, that finishes that one. Next one is for us to expand this. Right? We want to expand this out and write it as one of these. It's quite simple. Expand these things the normal way. So the first term times the first value, this times this, and then this times this, and that times that. All right? Same way. Right, let me leave these markings on it. So it's this times this, and this times this, and this times this, and this times that. All right, so if we write it out now, we get the 8 times 2 first, which is 16. And then we get the 8 times negative root 5 is negative 8 root 5. And then we get the root 5 times 2, which is 2 root 5. And then we get the root 5 times negative root 5 becomes negative root 5 squared. And so this is 16. This becomes negative 6 root 5. Negative 8 and 2 of the same thing. Negative 6 root 5. This negative root 5 squared becomes negative 5. Because the root 5 squared is 5. Then this 16 minus this 5 is 11. With 11 minus 6 root 5. That is answer. 11 minus 6 root 5. Answer is A. That is that. Next question. What is this equal to? So when you have these expressions, right? You're searching for perfect squares in these. You know, if you factorize them down with the lowest prime number possible, you're gonna end up with a perfect squares. The perfect square that's in this is 9. That's the same as 9 times 2. And this one is the same as 25 times 2. So I'm gonna write these two expressions as the square root of 9 times 2 plus the square root of 25 times 2. That's what I'm writing them as first. So this is the 9 and this is the 25. Then the square root of the 9 is 3. And then you leave out the square root of 2. So it becomes 3 times the square root of 2 plus square root of 25 is 5, and you leave out the root 2. So you're going to get 5 root 2. And then when you put it all together, you're going to get 8 root 2. But this question is numeric enough. So let's see if the calculator would give us the answer. Let's see. Just want to see if the calculator would give us the correct answer. If we were, it would simplify it for us and give us this. Let's see. The answer is this one. This one is the answer. Well, let's see if the calculator would give us that answer as well, because it is numeric and some calculators will. I always say to the student, if the question is numeric, let's see if the calculator will give it to you. So I'm gonna do root 18 plus root 50. And then see what it gives me. See if it gives me a simplified. There you go. See there? 8 root 2. So you see, these questions are like giveaways in an exam. You have a calculator. So you get 8 root 2 because the calculator is going to bring it down to the lowest terms. All right? So that is it, 8 root 2. So, you are blessed to get a question like this on an add math. I tell people all the time, that add math multiple choice is much easier than CSEC, because they give you all these numeric questions on the add maths that you can use your calculator. You can't use calculator and CSEC. In addition to that, you have only 45 questions at the same time on the add maths paper, and a lot of them can be solved, can be worked out with a calculator that you are allowed to use. So I don't know CXC decided to put a question like this on the exam paper when the calculator can work it out. It just depends on the type of calculator that you have. All right, so make sure you get one of those calculators. All right. Next question. Let me leave the calculator. I think there are others that we can use the calculator for here. Let me show you. And this one now. This one again is numeric. This one again is numeric because the question is asking us for 2 to the z. It's telling us that z is this. So all I need to do is take this and drop it on the 2 on the power for the 2 for the z right there now. That's all I need to do, on the calculator and work it out. And let's see if a calculator can work it out. So I'm gonna put 2 raised to the power. Let me zoom this up somewhere so you can see it. And I'm just gonna put this as my power. I'm gonna put this thing as my power in the calculator. So my power becomes 5 plus log to base 2. I'll make sure you have a calculator that can do this, of 3. Here's the answer, 96. So the answer is this one, 96. All right? And that is it. But let's say it was not numeric, I have to work it out. So you see the calculator can work it out. But let's say it was not numeric, I have to work it out. So I just showed you that you could use the calculator and work it out. But let's say it is not numeric, you can work it out. What it is that you want to simplify this down as far as possible. All right? Especially this side. Okay, you can get 2 to the z out of this expression if you write this in log to base 2. So this 5, I want it to become a number log to base 2. So I therefore multiply it by log to base 2 of 2 first. So let's proceed. Let's proceed. Let me zoom up and show you the work. In case the question was not numeric and you have to do it with some letters or some X and some Y, right? So I'm going to work on this. So I want to bring this to one expression, log to base 2. All right, so the z would be equal to 5 times 5, and then this 5, because I want to write the 5 as a number, log to base 2. I'm going to multiply it by log to base 2 of 2. This is same as log, right? This is same as log. Let us write my log like that. LG from back in the day. LG for me is log to base 10. Or log to base 2. That's why I write log, LG. Instead of writing out the word log, I write LG. No problem. And then I'm going to add now. So this is basically to get my 5 to become a number log to base 2 of 2. To become a log to base 2. So I'm going to multiply up the 5 up here. Raise the 5 up there using that law of logs, right? And then now I'm going to write back this thing, which is plus log to base 2 of 3. Then this 5 comes up here as a power. So the z becomes log to base 2 of 2 to the 5th power plus log to base 2 of 3. Then 2 to the 5th power is actually 32. 2 to the 4th power is 16. And then 16 times another 2 is 32. So this is really log to base 2 of 32. So this is at z equals log to base 2 of 32 plus log to base 2 of 3. And when you add logs with the same base, you basically become the log to the same base of the product. You multiply these. Right? Let's make this a little smaller. Let's make it a little smaller. You can still see it. Right? Right. So we're going to multiply these two. So the 32 times the 3 is 96. So the z becomes log to base 2 of 96. Right? I'll get the 96, the 3 times 2. 3 times 32, or 32 times 3. 32 times 3 is the 96. So that's how I get the 96. 32 times 3. And then once you have this, this is a power, this is a base, this is a number. Your number is equal to this base raised to this power. So you go like this. This number 96 is equal to this base of 2 raised to this power of z. That's it. 2 to the z. 2 to the z is 96. The answer is 96. That's it. That's how we do it if it was not numerical. But because the question is all numerical, you could just use it, put it in a calculator. All right? And let's remind ourselves of this rule. All right? That connects logs and indices. Let's write it over here. Write it right here, so we can remember. The log of a number Yeah, let's make the pen because it's 3. Right. So the log of a number to a base is actually equal to a power. This number is equal to this base raised to that power. So the number is equal to the base raised to the power. And this is the relationship between logs and indices. Interchangeable. We can go from this to this and from that to that, both ways. So remember, number, base, power. Number, base, power. That's the relationship between logs and indices right there. And let's put it in a box. And this is just for revision purposes, all right? And you have to be able to go from logs to indices or from indices to logs by identifying the log, the number, the base, and the power. The log of a number to a base is equal to a power. The log of a number to a base is equal to a power. That number is equal to the base raised to that power. That's the relationship between logs and indices. All right, let's continue. So back here now. So this question says, given that this is equal to 6, then the value of x is what? Now, if I'm in the exam, and I can't do logs, I just try each of these values in this. For the x, try each of the values in x until I find the one that gives me 6. Because the answer is on the paper, right? If I can't the logs. But then I'm going to use this law. I'm going to actually use this law right here. So I'm going to treat this as my number. I'm going to take this base raised to that power. All right? So using this law up here that we just wrote. In fact, what I should do is move this down here so now, because it is being applied here. Right? So let's leave that there instead. Go back for this now. So this becomes my number, x cubed. And in fact, what can happen to the laws of log say that this 3 can come to the front first. So if we do that, we're going to get 3 log to base 2 of the x equals 6. And then I divide by the 3. I get log to base 2 of x equals 2. And then what it means is that this x becomes a number. This is a base and this is a power. So the number x is equal to this base raised to this power 2, which is 2 squared. And 2 squared is 4. So the answer right here is 4. All right, that is it. Now, if we did not do the x cubed first, then let's do it another way. Right here. So we could say, or we could say this is our number equal to 2 to the 6th power. So we could say x cubed equals 2 to the 6th power. Right? Then I want to find x. I need to cube root both sides, or raise both sides to the 1/3. So if I raise both sides to the 1/3, then it will be x cubed raised to the 1/3, which is cube root. Then I have to raise this side to the 1/3 as well, which is like this, equals 2 to the 6, and I'm raising that to the 1/3 as well, because I'm trying to eliminate the power 3. This makes it become an x1. So we get x, we get x on this side equals, and then when I multiply these now, 6 times a third is 2, which is 2 squared, which will still give me my 4. So you could do it that way and get the same answer. All right, that is that. All right, logs is a beautiful topic, and just like tricks, because you have multiple ways using the laws to solve the questions, but you have to know the laws. That's a key thing for logs and indices. You have to know the laws. When you know the laws, the questions become very easy. So you have to take time to learn the laws, and learn the laws from left to right and right to left. Learn them both ways. Don't just learn from left to right or from right to left. Learn the laws both directions, from left to right and from right to left. What I mean? So for example, the law that says the log of A plus the log of B equals the log of AB to any base, same base. You have to know this law going that way. But if you're given something like this, you have to know that you can break it up this way as well. That's what I mean by learning the laws both ways, from both directions. All right? That's what I mean. All right. When you know the laws, it becomes easy, just like trigonometry. When you know the identities in your head, your brain works like a computer, and you know which identity to use to solve a question. But you have to take time to learn them. Know them in your head. You can't fit all of them in your head. You don't have to depend on the formula sheet for it. All right, this question now. It says the log of p, log of x to base p is 6. And the log of y to base p is 4. And they're asking us to find this. We're going to use the law of logs. That's the log of a quotient becomes the log of the difference. All right, so this thing becomes equal to the log of p of x. You divide, you subtract the logs from the log of p, log to base p of y. That's what they're doing here, really, you know. That's what they're doing. This question is also numeric, really. It's a numeric question as well, kind of. You know, so you become the log of x, which is 6, minus the log of y, which is 4. That's what it becomes. And that is equal to 2. So the answer is just this 2 right here. Easy as that. All right. Use the laws of logs. This is the second law I just used, log of a quotient from the log of the difference. Becomes the difference of the logs. All right. Next one. This one says, give us this, and I want us to find x. So solving this one. All right. Now, let me show you something. When you're solving a logs equation, right? Like this is, there are two options you want to use, two approaches, one of two approaches. You want to bring it down to something like the log of a number equals the log of another number. I have the same base on both sides. This would mean that two numbers equal. That's option 1. So you want to get the same log of something to log of something else. Log of a number to a base equals the log of another number to a base, means that the two numbers are the same, or the two expressions are the same. That's option 1 when you're solving the logs equation. The second one is you want to bring it down to the standard thing, which says the log of a number to a base equals a power. And this then would mean the normal relationship that the number is equal to the base raised to the power. So it's one of these two things you always want to bring your logs equation down to. Because when you bring it down to this one, then you are solving this. When you bring it down to this one, then you are solving that. So when you bring it down to those, you solve this one to finish it, or you solve this one. And if I bring it down to this, you solve that. That is how you want to solve your logs equation. I bring it down to one of these. Now when I look at this, I see a 2 over here. But there's a number 2 alone over here. It means that it looks like I want to use this method for this question. Right? That's what I want to do, use that method. What it is that I want to know that the law says the log of sum of 2 logs equal the log of the product of the values. And they're the same base. So this side is going to become log to base 3 of the product of these two things, which is 2x plus 1 times 3x minus 11, and that is all equal to this 2 right here. Then it means that this is my number, this is my base, this is my power. So this number is equal to the 3 raised to the power 2. So it becomes 2x plus 1 times 3x minus 11 equals 3 squared. That's using this method. That's a 9. So this is a 9. Now the answers are on the paper, you know. And if you don't want to solve it out straight, what you can do is just try values in there for the x and see which one give you a 9. right? Because the answers are there. So just try try the values of x in that equation and see which one of them give you a 9. And that will be an answer. But then you could solve it, right? So if I'm going to solve it, I have to expand it out and transpose it into a quadratic equals 0. If I transpose it out into a quadratic equals 0. If I expand this side, then it is this time this first, which is 6x squared. Then the middle term is the sum of the far product and the near product. The near product is 3x. The far product is a negative 22x. 2 times 11 is negative 22. Negative 22 and 3 is negative 19. So my middle term is negative 19x. All right, negative 19x. So my middle term is minus 19x. Then this times this is negative 11. Then this 9 comes over this side to become a negative 9. Let me write equal 9 first. Write equal 9 first. And then I'm solving this quadratic. Right? I'm going to transpose this 9 and get 6x squared minus 19x. That is now minus 20 equals 0. So you see, it doesn't get any easier. Again, it could be easier. Just basically just try the values in there. Just try the values in there and see which one of them works, rather than to try to solve it. All right, let's try the values in there and see which one works, because the answers are there on the paper. I think it's less work to just try the values in there. But then if you're solving it right down, then we'll have to factorize. Let's see how this factorizes. Let's see how this factorizes. I'm going to use a trial and error. So let's say this is 3x and x. Let's try 3x and 2x to begin with. And the factors of the 20. Let's try 2 and 10. And you see, so much work I'm taking, rather than, just try the values. It's easier to just try the values. Let's say I'm going to go 4 and 5. That would work. No, let's try the other way around. Let's try 5 and 4. So this is 12. And this is 10. Times are different. I don't want the difference to, it's just too much work. Just too much work to try and factorize it. Because this is not a prime number. This is not prime. And that is not prime. So, you might have to go through the whole process, multiply the n coefficients, the factors of the 120 that add to the middle term. You don't want to do that on a multiple choice paper. Man, just try the values here, man. Picker. Try the values and see which one works. Let's do it like how we did in the example. We'll try the values from right here, actually. We'll try them from right here. Do it like a multiple choice. Just 4 values. Try it from right here. I'm going to erase and try it from right here. We get 9. Which one of them give me 9? All right. I'm going to try the values. Easier. Let's do it that way, like how we do it in an exam room. Practice that as I would do it in the room. So I'm going to try 5. Try 5. And I would set up my equation in the calculator, like bracket 2 times 5 plus 1 close bracket times open bracket 3 times 5 minus 11 close bracket. I get 44. So that one can't work. So 5 can't work. Let's try 4. Let's try 4. Get rid of the two whole numbers. Try 4. 4 works. So try 4 works. So 5 don't work. Try 4. 4 works. I try the two whole numbers. 4 works. So I'm seeing that when I try the 4, this becomes 8 plus 1. This becomes 12 minus 11 equals 9, which is correct. So 4 works. So the answer is 4. It's easier than to go through the whole factorization process with those that are not. You see, the n values were prime numbers. They can just look at it and know. You're trying to save time in a multiple choice, and the answers are there on the paper, so you don't have to work out everything. After you get to here, you see which one of the values were. Right? See which one of the values were. That's all you have to do. Our class now, I'm not seeing Josh. That's what I call it. All right, cool. Later. I'm in a class now. Online. Cool. All right, cool. All right. Sorry about that, guys. That was a parent calling. All right, so that is that, right? So sometimes, the answer is on the paper. You reach a stage, you figure it's going to take a lot of work. If you're going to solve it, just test the answers and see which one it is. It's only 4 answers there, right? It's only 4 values there. So just test them and see which one works. It's quicker, much quicker, right? The answer is on the paper, all right? So you don't have to waste time working on stuff. All right, so this one again, it says the value of x for which this is. Again, you can try values. You can try this. Just plug these values. For example, try these 2 first and see if any of them works, right? But anyway, let's go. It says the values of x. So if you notice now, these are base 3, both of them. Base 3. So when you're adding, well, so I'll have to break this up, right? You're adding, you're not multiplying. You're adding. No, this one means 3 to the x times 3 squared, plus 3 to the x equals 90. That's what it means first. All right? That's what it means first. All right? So this becomes 9 times 3 to the x. This becomes 9 times 3 to the x plus 3 to the x equals 90. And so this 9 times 3 to the x and 3 to the x becomes 10 times 3 to the x equals 90. And then you divide by the 10, you get 3 to the x equals 9. And if 3 to the x equals 9, then x must be 2. Because this 9 is the same as 3 squared. 3 squared. And so x equals 2. Right? But if you have a problem solving it, as I said, see, the 2 would work for you. And if I'm trying it, I'm going to try these 2 values first, for the x up here now. That's what I would do. And you'll see that this works. But anyway, that is the answer. It's 2. Just remember, guys, the answers on the paper for questions that look like they're going to give you a problem to solve. Try the answers in the questions and see which one works, right? Especially if you have one of those calculators that you can type anything in. But that is it. All right, next one. So the important thing with this question was to break this up, right? To realize that that is actually this. Laws of indices, that one. All right, next question. It says, the value of x for which this is equal to 2. It's almost the same question that we did up here a while ago. Almost the same thing. Just that now we know our minus. That one was a plus, we know our minus. Right? So it's almost the same thing. So because we know our minus, we're going to take the log of the quotient. So this becomes the log to base 2 of this divided by this, which is 5x plus 1 over 3x minus 5 is equal to 2. So I brought it down where we have now the log of a number to a base equals a power. So this number is equal to 2 raised to the power 2. We can write that 5x plus 1 over 3x minus 5 becomes 2 to the power 2. And this is equal to 4. And then to solve this now is a matter of cross multiplying, right? So we're going to take this and multiply it across here. We're going to get 5x plus 1 equals, when I multiply this by the 4, I'm going to get the 4 times 3x first, which is 12x. And then the 4 times the minus 5 is minus 20. I'm going to take this 5x and bring it over here and subtract from that 12x to get 7x. This negative 20, bring it over here, add to the 1, give me 21. I divide through by the 7, I get x equals 3. So that is it. Answer is x equals 3. So again, if you can't solve it, plug the values in there and see which one of them equal to in the calculator. The answer is on the paper. You don't have any business getting it wrong. The answer is on the paper and the question is numeric. So you just try which answer works in the question. If you can solve it, it's still a multiple choice, and you're blessed to be able to use a calculator. All right. Next question. This question now. So this question says, which of the following statement is true? So you have to know your laws of logging. This one is not right. Remember, the log of a product expands out into the sum of the two logs. So this is not right. So this one already is not correct. This is supposed to be a plus. So you see, this one is almost testing your knowledge of the laws of logs. Then no, this one says the log of the base. The log of this one not right either. I know if you look at it, look at this now. If the first one, yes, I don't think this right properly. I don't think that is the correct question, you know. God, look what I'm telling you that now. Look what I'm telling you that now. No, that this is correct. I don't think this typed properly. It's not typed properly. I think this is supposed to be the log to base b of p over q. Let me tell you why I'm saying that. Because I know that this one is wrong. Look at the answers. This is our one in it, this is our one in it, and this is our one in it. So them three are wrong, you know. So the answer must be that right one. So it means that the second one must be correct. I think this is a typo. The correct thing for right here, which I'll have to correct. And let me tell you what it is supposed to be. This is a typo. Let me see if I can just shade it out. Right. Shade it out and write what it's supposed to be. It's supposed to be log to base b of p over q. Which becomes the difference, which is correct. So this question is testing your knowledge of the laws. Let me write what it is supposed to be. This is a typo. This is a typo. Otherwise, none of the answers there would be correct. So this is supposed to be log to base a of p over q. That's what that's supposed to be. All right? Which would mean the second one is correct. That's the second law. And then this is the third law. The power can come to the front as it is here. So this one is correct. This is a typo. That is clearly a typo. This is correct. So the ones with the I are all wrong. So you know the correct answer from the book. So if I declare that one wrong, you know, because this have a I, this have a I, and this have a I. So those are all incorrect. Because the I is incorrect. So this one not it, this one not it, this one not it, this must be it. The second and the third one are correct. Alright, so this is the answer. That thing is a typo right here, guys. I have to go and correct that. It's a typo. Sure, it is a typo. All right, so that is that. All right, next one. 1 and 3. All right. We'll come to this surge. Again, you can put in a calculator, you know. But we can put calculator and see what we would get. If we get one of the answers. Don't forget that you have a calculator with you. Fraction. Root 5 minus 1 over 1 plus root 5. What is now? So it's giving me this answer right here in search form. This, which is same as a half bracket 3 minus root 5. Right? So which one of them is that? See there now. Calculator do that, you know. All right. So my answer is on the paper. and you can use a calculator. So when the questions are numeric, you use your calculator. But let's work it out in case it was not numeric and you had some X and Y in it and so on, right? That's some A and B. What would you do? You basically want to rationalize the denominator. That's what they did in this question. Rationalize the denominator. We don't want a third under here. So multiply by its conjugate. But you see, because it's have the root 5 in front and top, you want the arrangement of the values. The arrangement of the values, the irrational numbers to be in the same arrangement, numerator and denominator. So I'm gonna flip around these and write this instead as root 5 minus 1 over root 5 plus 1. That's the first thing I'm gonna do. Set them in the same arrangement. So you have the surds part and then the real part, or the surds part and the rational part. Surds part, rational part. All right? Surds is an irrational number, remember. So I set out in that consistent order first. Then I want the denominator to become rational. I have to multiply it by its conjugate to form the difference of two squares. So what is a conjugate? The conjugate is like you put by the same expression, but you change the sign to a minus by setting up the difference of two squares. So multiply under here by root 5 minus 1 and multiply the numerator by the same thing, root 5 minus 1. Now what you've realized now is that on the numerator you have the perfect square, and on the denominator you have the difference of two squares. Let me write that line for you. Don't need to write it, but I'm going to write it still. The numerator becomes root 5 minus 1 squared. And the denominator, the difference of two squared, becomes root 5 squared minus 1 squared. This time, this is the difference of two squares. So, just to save space, I'm going to put it here. It becomes, put it on here. When I expand this, I'm expanding a perfect square. It becomes the first term squared. Let me write it out. Root 5 squared. I could just write 5 if I want, but just to show the working. Then twice the product of the 2. Expand a perfect square. Remember, the middle term is twice the product of the 2. I have to multiply these two things. I get negative root 5 and then double it to get negative 2 root 5. And then the second term squared is a 1. Negative 1 squared is 1. And then dividing that now by these. The root 5 squared is 5 minus the 1 squared. The 1 squared under here is 1. So on the denominator, we're getting a 4. Let me make this a little smaller. I'm actually writing more than we need to, but it's just a matter of showing the work. All right, just to show the work. So this is a 5. This is a 5. And this is a 1 makes 6. I'm just going to write 6 minus 2 root 5 divided by this becomes 4. And then you're dividing, you can divide 2 by 2. You can divide the numerator by 2 and divide the denominator by 2. So you divide the numerator by 2, you get 3 minus root 5 over divide the denominator by 2, you get 2. That's what it reduces to. Right? So like I multiply the numerator by half, and multiply the denominator by half. That's what it is essentially. Right? And so you get this. And this is the same as this last expression here. So same as this. This is the same as this. Right? Just have to put the half in front of it. So divide by 2 is multiply by half. So it's the same thing. And that is it. So you see, we could go through the calculator, guys, but I just do the working out just in case I'm going to put like some X in here, so instead of 5. Right? Just in case they do something like that with the same question. All right, so let's go. This one again, calculator can work that out again. Let's see. It's numeric. So calculator can do it. This one over here. Let's see. So it would be fraction root 2 minus 1 over root 2 plus 1. And you look at the search formula to get the answer in. And there it is. That is the same as 3 minus 2 root 2. Which is this. That's the answer, Quick and fast. Because you have a calculator. You guys don't know, blessed you are to be able to use a calculator in a multiple choice examiner. Any multiple choice exam to do questions like this. All right? and answer is right there on the paper. But if you were to work it out now, you put an X right here, for example, and an X right here, you have to work it out. They want to be a process. It don't matter that there was a number there, it's a process. So they are already arranged consistently. And so I'm just going to multiply the numerator by the conjugate of the denominator. Multiply under here. I want to rationalize it. So I'm going to multiply. Let's put it here in the right mode first. I'm going to write root 2 minus 1 over root 2 plus 1. This is the same question. Just that instead of 2, instead of 5, we now have 2. Same question, really. I'm going to multiply numerator and denominator by the conjugate of the denominator because I'm trying to rationalize the denominator. So I multiply by root 2 minus 1 because I multiply numerator also by root 2 minus 1. Numerator becomes a perfect square. So we're to write it again, which I don't need to. Let's expand the perfect square, but let's just write it still. It becomes root 2 minus 1 squared over, this is now the difference of 2 squares, which is root 2 squared minus 1 squared, just to show the work. Expand the perfect square in the numerator. First term squared is root 2 squared. Twice the product of 2 is minus 2 root 2. Second term squared is 1 divided by, this becomes a 2 and this becomes a 1. 2 minus 1, that's a 1. So what does this become? This is a 2, you know. 2 and 1 is 3. So I get 3 minus 2 root 2 divided by a 1, because that becomes a 1. So this is the answer. 3 minus 2 root 2. So this is the answer. So they give you with x and y's and so on. The process is the same. The process is the same. All right? But I'm sure they're going to give you numeric just the same. And then they will give you numeric, believe me. All right? Let's continue. This again, calculator. See? Numeric. Calculator. Put this in the calculator and see which one of these is equal to. So I'm in the exam room. This is what I'm showing you. Once the question is numeric, use a calculator. Just type it in the right way. The fraction 2 raised to the power of -1 divided by 8 raised to the power of a third. You set it out the same way. See? 0.25, which is this. Answer is a quarter. Quick and fast. Use a calculator. All right? But if they give you some letters with it now, like some A's and some B's, and you have to work it out, then you have to know that you're going to use the laws of indices. All right? Now, this 2 to the minus 1 really becomes a half. So I can write it like so. So this becomes 2 to the minus 1 becomes a half on there over this third power means cube root. Cube root. So I'm doing the cube root of 8. Or I can do it the other way and write the 8 as 2 cubed. So I can write 2 cubed raised to the power third. And I can leave this as indices, you know. I treat it like an indices question. I can leave this as 2 to the minus 1. 2 to the minus 1, like that. All right? And then now it will become equal to, and I multiply this power now. I get that 2 on here, so I get 2 to the minus 1 over 2 to the 1. And so now I'm dividing. I'm dividing this by this. When you divide numbers with the same power, you subtract the powers. So it becomes 2 to the minus 1 minus this one. So it becomes 2 to the minus 2. And 2 to the minus 2 means 1 over 2 squared, which then is a quarter. I mean, that's not the only way to do it, but you know, you get the answer as you see. But that's not it. That's not the only way to do it. If I do it another time, it's gonna be done. All right. But again, I could just write this instead of doing it this way. Let me show you. I'll show you the other way. If I didn't do it as an indices question, do it in red down here. Draw a line down here and do it in red. So I could say, or I'm going to write this 2 to the minus 1 as half. over, I'm going to do the cube root of 2. That means the cube root of 2. Cube root of 8, sorry. Cube root of 8 is 2, so it will become equal to a half divided by 2. Half divided by 2 is the same as a half times a half, because the divided by 2 is to multiply by 2. It's to multiply by a half. To divide by 2 is the same as to multiply by a half. To divide by 2 is the same as to multiply by a half. And so this will become equal to a quarter, just to say. So this is just another way of being done. If we don't do it like an indices, you do it like an indices question. You will just do it like, just solving some numbers or simplifying some numbers. All right, that is that. This one again, numeric. Calculator again. Calculator. Drop this in the calculator, get down. All right? Well, if I give you an x and y, I have to simplify it. This first, this negative form means reciprocal. So this becomes equal to the reciprocal of this. That's what the negative form does. The reciprocal of it. So it becomes 16 over 25 to the half. Now the half means square root. So it will become the square root of 16 over 25. When you take the square root of that, you take the square root of 16, you get 4. Square root of the 25, you get 5. And that's as 4 or 5. But again, you could just type this in the calculator exactly as it is, and you get the answer. Because the question is numeric. All right? Simple as that. Next question. So notice when I drop the negative sign, I take the reciprocal. I flip the 25 and the 16. The negative means reciprocal. So I flip the, drop the negative and flip the 25 and the 16. All right? That's what we do. All right. Next question. What is this equal to? Again, if you can't work it out, put in the values in there for the x and see which one works. Which one them give you 2. All right. But to do this question though, since this is 4, this is 2. 2 sides can be brought to the same base 2. So this 4, I'm going to write as 2 squared. So firstly, it becomes 2 squared raised to the power of x plus 1 equals 2. And this 2 is same as 2 to the 1. I have to multiply these powers now. So I get 2 to the 2x plus 2 equals 2. And this is 2 to the 1, 2 to the 1. So the two bases are the same on both sides of the equation. It means that the powers are equal. Right? So it means, therefore, that the 2x plus 2 is equal to 1. So you're solving for x now. You're going to transpose the 2 and divide by the 2. So the x is going to be 1 minus 2 divided by 2, which is negative 1 over 2. So the answer is the first one. That is it. All right, that is it. If you're solving it, again, you could also use a calculator. Everything here is numeric, right? Next question up here. Similar question, almost the same thing, just different values now. So again, I'm going to write this 9 as 3 squared. So I'm going to write 3 squared raised to the power x plus 1 equals this 3 is the same as 3 to the 1. And I multiply these powers now. So I get 3 to the 2x plus 2 equals 3 to the 1. That means that these two powers are equal because both sides are on the same base. So we can say, therefore, 2x plus 2 is equal to 1. The same answer now, negative half. Transpose the 2 and divide by this 2. The x equals 1 minus 2 over 2, which is minus 1 over 2. So that's negative half right here. Same answer. So basically the same question with the values change. Right? That's it. Come to this one now. Another question similar. What we're gonna do is bring everything to base 3. All these numbers can be brought to base 3. So bring everything to base 3. So the 27 is 3 cubes. So let's write it like this first. This is 3 to the 1. This is 3 to the 1 times. This is 3 cubed. 27 is 3 cubed raised to the 2x equals this 9 is 3 squared. 3 squared raised to the x. Laws of indices, so we have to multiply these powers. So it becomes 3 to the 1 times 3 to the 6x equals, multiply these two powers, you get 3 to the 2x. When you multiply numbers with the same base, you add the powers. So this side becomes 3 to the 1 plus 6x equals 3 to the 2x. So since both sides are on the same base now, you can draw the conclusion that the powers must be equal, right? So we can say therefore 1 plus 6x is equal to 2x. And if I transpose, I'm going to take the 2x over here and subtract and take the 1 over there. So I'm going to get 4x equals negative 1, which then means that the x is equal to negative 1 over 4. Answer is this one, A, negative 1 over 4. Right, easy stuff. And that finishes the logs and indices, series, logs, and indices done. All right, series, logs, and indices done right there. One bank of questions, one big bank of questions here. Then we're gonna go down and do this is coordinate geometry coming up next, because we did these already, which is sequence and series. The next topic we're looking at now is coordinate geometry, which goes into vectors over here, and from vectors we go into trigs. Coordinate geometry, vectors, trigs, and then I think we'll be done. That's it. So today can be a short session. We'll be done. All right, there are a couple questions on the specimen paper, especially the statistics questions that I would maybe want us to look at before we finish. But let's see how we go. Right? What time is it now? Yeah, let me do the next topic, the coordinate geometry. Let me take a short break. Right? Let me just do these coordinate geometry questions, and then we take a short break. Right? So that's the first coordinate geometry question, number 21. These are lines, so it will become easy when it's just lines. It says lines, that one and that one intersect at P. What are the coordinates of P? Now, I notice that all these x values are different and all these y values are different. So any one of them I find first, I'll be good and okay. All right? I can use elimination. So basically, I'm solving these two equations simultaneously now. Solving the two equations simultaneously. Right? So I can decide that I want to eliminate the y's, or I can decide I'm going to eliminate the y values. So I'm going to multiply this one by 4 to get this to become a 4y. Okay, I multiply by a negative 4 to make it become a plus y. So let's say I'm going to take this equation. Let's write what I'm going to do here. I'm going to take this equation and I'm going to multiply it with a negative 4. Why? Because I want this to become a positive 4y. So then it will become equal to negative 12x plus 4y plus 20 equal 0. All right? I multiply that one with a negative 4. Let's check it. Good. And I'm going to add it to this one now. I'm going to add it to this one. Add it to the top one. So the top one is 7x minus 4y plus 25 equals 0. I'm going to add those two equations. Because when I add these two equations now, because these are of opposite signs and same value, they will eliminate each other. So it's negative 12y and 7y is giving me negative, not y, x, negative 12x and plus 7x is giving me negative 5x. These are eliminated. When I add these two, I'm getting 45. I'm getting plus 45 equals 0. So I can transpose this 5x over here, make it positive, and so 5x equals 45. I divide by the 5, I get x equals 9. The only one with a 9 is this one. So that has to be the answer. We have to go any further. If you want, you can try the values, but I guarantee you that that is correct. You can try the 22 if you like. I try the point if you want to try the point in one of the equations fully and see if it works. Right, so you can maybe try it here. All right, let's also try it here. It's gonna become 9 times 3 is 9 times 3 is 27 minus the 22, but y is 22 and minus 5 is it equals 0 for true. So notice that the point is correct, right? So that is it. Anyway, that's it. So just once again, but all the values are different. Any x value you get, you would have found. So this is found by solving equations simultaneously. That's it. Next question. It says the line, so another simultaneous equation. These two lines intersect at what points? Simultaneous equations again. This time, because I have y as a subject here, I can use a substitution method. Again, all x values are different, right? So if I eliminate the y, I just find the x value, whichever one matches that x value here is the answer. So I'm going to take this right here, that y is saying y is equal to on this line. I'm going to bring it and substitute it for the y right there. Simple as that. I'm going to sub. I'm using a substitution method this time. So when I use that substitution method, this equation, when I substitute for the y, becomes x plus 3 into 2x minus 7 equals 7. And that's what I'm solving. So x plus 6x minus 7 is 21 equals 7. This and this gives me 7x. This 21 goes over here and add to the 27 to give me 28. And I divide by the 7, the x is equal to 4. So the answer that corresponds to a 4 is this one. X equals 4. You can test it because I'll put 4 here. Then 2 4s, 8 minus 1. Minus 7 is the 1. So it works. All right. So that is it. So the answer is, as I said, the A. Done. So simultaneous equations. Right? Solve them by elimination or substitution, depending on what you have. Next question. This again, it says the line L passes through that point and is perpendicular to a line whose equation is this. What's the equation of that line? All right, let's have line L. All right. So line L passes through this point. So that's the point that you're going to use. The line that you want passes through that point. But it is perpendicular to this. All right. So the line, the gradient of line L, if you call this, let's call this line line 2 then. Line 2. Line 2. The gradient of line L that we want, let's write L this way, is minus 1 over the gradient of line 2. Because they are perpendicular. Perpendicular lines have negative reciprocal gradient. The question is, what is the gradient of line 2? To get it, you have to make y the subject. All right? Make y the subject of this. So let me shift this over a bit. I'm going to take this now, make y the subject of it, right? This one. So make y the subject of that one. Then y is going to be, I have to divide through by the 4. It's going to be negative 3 over 4x plus 7 over 4. I make y the subject. If I transpose it, I make y the subject. That's what I'm going to get. So this right here is my gradient. This is the gradient of this line, which is my M2, gradient of line 2. So the gradient that I want over here, gradient of line L, becomes the negative reciprocal of that. Now, negative reciprocal can be done quickly by flipping what we have and change the sign. That's how we do negative reciprocal gradient. Flip what you have and change the sign. So if two lines perpendicular, and you know the gradient of one of them, you flip the one that you have and change the sign to get the gradient of the other. So if you flip this first, you're going to get negative 4 over 3 and change the sign to 4 over 3. So using this gradient and this point to get the equation. Let's write the equation over here now. The equation, format for the equation right up here, is y minus the y of at a point equals the gradient of the line that we want into x minus the x value at a point. And this is our point. Right? That's our point. And the line is line L. So using that equation or that method to do it. And that's not the only way to do it, but good enough. Then we would get y minus, and the y value at the point is 5, equals the gradient is 4/3 into x minus the x value at the point is 6. And then how do we get this one now? I multiply the 3 over here over this side. I multiply the 4 inside here. All right? I don't want that space working with, but let's see. So I will get, let me shift it over. So I'm trying to make some space. It's a little smaller too. So this is the equation, right? Trying to work out here somehow of line L. All right. So when I multiply by the 3, it becomes 3y minus 15 equals, and I multiply inside this, so with 4, I get 4x minus 24. Right? I'm gonna change this to red. Change this to red. And this one as well. To red. Oh man. All right, I'll change them. It looks so good. All right, let me in red then. So the gradient of line L is minus 1 over the gradient of the second line that I spoke about. And it works out to be the gradient of line L is 4/3, which is what we used here, right? Because we apply this equation here. We're applying that equation though. Here's up a line, we apply. All right, so we want to see which one this is now. So if you notice, they have transposed everything over onto the left side, right? So then it will be 3y and minus 4x. Then this 24 comes out become a positive 24, right? It becomes 24 minus 15. 24 minus 15 is 9. Something wrong. Something is wrong. I'm not seeing a 9 there. That's one of my answers wrong. I'm not seeing a 9. 24. It says 3y. One of these and one of these. The 3y. It's 3y minus 3y and minus 4, but that answer not there. Unless I put it the other way, but the transpose over this side instead. And do that too, transpose over this side instead. So you get the 4x minus 3y. So we transpose over the other side instead. Transpose these over here. We're gonna get 4x minus 3y, and you're gonna get negative 24 plus 15 minus 9, and that equals 0. Yes, so this is it right here. Yep. So go, guys. Sometimes, take a little bit of time. But that is it. But it don't matter. I mean, it's just it's just working it out. You have to find a gradient of find the perpendicular gradient, then use the point gradient form of the line to get the equation. And that's not the only way to do it, but a good enough way. All right. Next question. Next question here says the line through this point, and this point is parallel to a line with this equation. So if it's parallel, it means that the gradient between these 2 points is equal to the gradient of this line. That's what it basically is saying, So this line now, if you write it y as a subject, you get that y equals minus 3x plus 21. Which means that the gradient of this line, call it line 1, is equal to negative 3. Based on the fact that they are parallel, it means that the gradient of PQ, gradient between these 2 points, is equal to the gradient of this line, which is -3. So let's set up the gradient between these 2 points now and equate it to -3. Now, what's the gradient between these 2 points? It is the difference in y. I'm going to use this point minus this point, q minus the p. Right? You have to stay consistent with the way you subtract the values. So this y value minus this y value first. Difference in y, which is 8 minus 2 over difference in x, which is 6 minus k. 6 minus k is equal to -3. And solving this now for the k. So this up here, so is a 6, and I can multiply this across here. So I'm going to get 6 equals -18 plus 3k. Looks like an 8. Because this 18 come over and add to the 6 to make 24. So if I continue right here, I'm going to get 24 equals 3k. And so the k equals 8. So the k is 8. That is it. All right. So basically, we call the parallel. First, you have to get what the gradient of this line is, which was -3. And then you put the gradient between these 2 points, equate it to -3. That's what I did here. And my gradient is difference in y over difference in x. Rise over run. You have to stay consistent. If I do this x value minus this x value for the difference in this y value, sorry, minus this y value for the difference in y, then I have to do this x value minus this x value for the difference in x. I can switch around the order of why I subtract them. Right? Because gradient has direction. So you have to stay consistent with the direction. All right, what to go to that? Look at time check. We'll finish this part. When we finish the coordinate geometry, we're going to take a short break. 10 minutes break. Everybody okay? Like a spot check now. Are all right?
Yes, sir.
Yes, sir.
All right. This is a similar question, almost the same thing as that. Almost the same thing. So you see, questions are repeated. So again, they give us these 2 points, according Q and R this time. And they set a parallel to this line. Almost the same thing. So again, follow the same process. This line right as the equation of in the standard form will be y equals minus 2x plus 10. This time the gradient of this line is a -2. But because they're parallel, then the gradient of the RQ must be equal to the gradient of that line, which is equal to -2. So then the same process, the gradient between these 2 points is -2. Again, you have to decide the direction that's subtracting. Let's say we're using this point down here minus this point. We do the difference in the y values first because it is rise. So it's 8 minus 2 first. So it's 8 minus 2 over 4 minus h. Difference in x is 4 minus h equals the -2. All right, and you solve. All right, you solve. So this is a 6 equals, multiply this denominator across here. I get -8 plus 2h. So this 8 comes over here and add to that to give me 14. So we can literally do the same way. And so 14 becomes 2h. Divide by the 2. The h is 7 this time. So the h is 7 this time. All right, that's that. So you see almost the same thing. Then we come to circles. So we just did some lines questions. Now we're looking at circles. These are circles questions. It said this point is on one diameter. This point is on one diameter of this circle. The coordinates of the other end of the diameter is what? So remember that if you have a circle and you know a point on one diameter, if you know the center of the circle, then on the other diameter is such that the And distance from here to here is the same distance from here to here. So the change in x values from the point that you know to the center is the same change from the center to the other point over there. That's the method we're going to use. So if I leave this sketch, let me leave that sketch. I'm going to put on the coordinates of the point that we know, which is a 2, 3. And we have the equation like this, right? The center point is minus half of this value and minus half of this value. So the center point is 5, negative 1, right? Because if you complete in the square to get it in the standard form, the circle, this is the general form. If you complete in the square these two values, you're going to end up firstly in the bracket. So you're going to end up, if you complete the square of the x values, you don't have to do the whole thing. Between these two values, you're going to end up with a x minus 5 in the bracket, right? Plus some stuff. And then if you complete the square of these two values, you're going to end up with a y plus 1 squared in the bracket plus some other stuff. That's what it's going to be. So the center point of the circle is 5, negative 1. Right? 5, negative 1. Remember the equation of a circle. Let me write it up here. Let me write it above here. Equation of a circle in the standard form, right up here, is x minus a squared plus y minus b squared equals the radius squared. That's the standard form, you know. So to go from this format to this format to get the coordinates of the center, which is AB, and the R is a radius. So the center is AB and the R is a radius, right? Then you have to complete the square of these two values, which means that half of this negative 10 coming here, it becomes negative 5. Then half of this positive 2 going here, it becomes positive 2. And then now, since you have a positive 1 in here, and that's a minus b, it means that the b value is minus 1, because negative b equals positive 1. And then because you have a minus 5 and you have a minus 8, then clearly the a is 5. So the center point, which is AB, becomes this. So the center point AB, let me write it down. The center point AB is that. Let me write it. Center point AB. Center AB becomes 5, negative 1. The value that you get when you try to complete the square, it's here in there. Right? This is a plus. Oh, man. This is a plus. I'm just trying to clean it up. This is a plus. All right. So now that you know the center point is 5, negative 1, how can I reason it out faster? So the center point is 5, negative 1. So I'm writing the center point now up here. I'm putting it on the diagram up here. So now, right? 5, negative 1. 5, negative 1. So you look at it. The change from here to here is a plus 3 now. So to get to the other diameter, okay, let me draw this diagram down here instead. Let me draw this diagram down here in the space because we can't put it here. I'll work it out. Turn this arrow down here now instead. So I'm putting in the center point on the diagram there. So I'm saying the change in the x value, because this length and this length is the same, and same straight line throughout, right? Across the diameter. So to get the coordinates over this end right here now, let's use the red. Since you added 3 to go from here to here, you have to add 3 more to this 5 now. So you know, so answer one of these, right? Right? So you're gonna get 5 plus 3. 5 plus 3 for the x value. And then for the y value, you subtracted 4. Subtracted 4 now. Because you go from 3 down to negative 1. So you subtracted 4. So you're going to start at this negative 1 and subtract 4 more. Or subtract 4 again. So let me write it. So it's going to be a negative 1 and you have to subtract 4 more. All right? Simple as that. Because you go from here to here, you add 3. And to go from here to here, you subtract 4. All right? That's what it is. And this is a way to indicate and this for those who maybe will get it one day. Let me write it here so like this. So I'm saying to go from 2, 3 down to 5 minus 1. Let's do it this way. Here, so we add 3. Here, so you add 3. And here, so you subtract 4. So same plus 3 and minus 4 we're using there. We have the same change between here and here. So your final point is 8 negative 5. So your answer is right here. And this is an easy enough way to do it. What go with that? But okay? Hello, students. Are you okay?
Yes, sir.
All right. So I'm using this point right there. All right, the center point. All right. So let's do the sketch here. Let's see. Next question. This one says the coordinates of a center. So this one is a giveaway, right? The center point. Remember, the equation is in the form. Let's do the blue. The equation of a circle is in the form x minus a squared plus y minus b squared equals the radius squared. They're not asking us for the radius, they're asking us for the center point. So if we're comparing this with this, then the center point is AB. What do we have? You have the minus A equals minus 1. So the A equals 1. But then you have the minus B equals positive 3. So minus B equals positive 3. So B equals minus 3. So then this point becomes 1 negative 3. I mean, you can look at it and know, it's the negative of this is this value and the negative of that value, right? Simple as that. And the negative of the whole of that and the negative of the whole of that is the center point. So it's 1 negative 3. I was trying to show some work, but that are the case, I don't even need any work. I can look at it and know. All right. So it's 1 negative 3. All right. So let's continue. That finishes that one. If I wanted the radius, it would be 6. This would be 6 squared. Give it a third of 6. So I wanted the radius would be 6. All right. If I wanted the radius. But I wanted the center point this time. Over here now, it says a circle, this center and this radius, which equation, show these equations. So you can literally just write the equation first and then expand it out, right? So that's what I would do. I would write the equation, and the equation will be x minus 3 squared plus, and because that's a negative 2, I'm going to get y plus 2 squared equal, this is the radius, so this becomes 4 squared. Then I'm expanding this and transposing everything to leave 0 on the right side. So I expand this side, I'm gonna get x squared minus 6x plus 9. Expand this, I'm gonna get y squared plus 4y plus 4. This 16 goes up, become negative 16 equals 0. So if I consolidate these values now, I'm gonna get, this is gonna become x squared plus y squared first. This is the only x term there, so it's negative 6x. It must be the silent sign of this. That's only negative 6x one. It must be the answer. Negative 6x. This is plus 4y. Negative 6x plus 4y. This is something I can know the answer without finishing the work, right? Now this right here now is 9 and 4 is 13. 30 minus 16 is negative 3 equals 0. So this is the answer. But you could know, if I may get the 6x right, this is negative 6x, you could know. That is that. All right. So that is the answer right there. Next question. A circle referred to in the general form that the coordinates of a center. All right. So again, the center, if you compare the square of these two, you're gonna get the x minus half of this squared minus the square of this, which is 1. And I put the y values together, so you're gonna get y plus half of this 4 is 2 squared minus the 4. And then subtract back that 11 equals 0. You're asking us for the center. It's a two-part question. Did they ask for the radius next? Yeah, they wanted the radius. So let's finish it. So because I don't want the radius, I'm going to finish this. So it's going to become x minus 1 squared plus y plus 2 squared. And look at the values now. This is negative 15, negative 16. They go on this side to become 16, but 16 is the same as 4 squared. So it means that the center point is 1, negative 2, and the radius equals 4 units. So 1, negative 2 looking for right here for the answer. 1, negative 2 is this. And the radius is 4 right here. That's it. All right, next one. Another 2 lines question. So the point of intersection of that line and the circle, or line and circle, is which of these points? Again, the answer is on the paper now, guys. So I want to see which one is. I don't have to solve them simultaneously now. But look here now. You see all these values is just 1 and 3. 3 and 1. Right? When I drop all those values in the circle, they're gonna work. They're gonna work, you know, because 1 squared plus 3 squared, whether they're positive or negative, is gonna give me 10. So I know that this is okay for all the points. I just need to see now which of the coordinates satisfy the first equation. So I'm going to test them in the first equation. I'm not going to solve them simultaneously. It's going to take me too much time, I think. I just want to see which of the points satisfy the equation y minus x. For example, y minus x equals 2. That's what I want. If I transpose this, I want the difference between the y and the x to be 2. So I'm taking this equation and I'm putting it like that. So I'm looking for when the y minus the x is 2. Positive 2, you know. Now, is this 1 minus 3 equals 2? No. So this one fails. So the first one out of it, this fails. This no work. Is this minus 3 equals 2? No. This no work either. Now, is negative 1 minus negative 3 equals 2? Yeah, this work. This work. Them two are working on this work and this work. We need to test these now. Now, is negative 3 minus a negative 1 give it 2? No, this don't work. This doesn't work. These two work. This work and this work. Can try them. Y, negative 1 minus a negative 3. That equal 2 enough for that point here. Let me write the test of it. Test. So I'm saying for this point, it is negative 1 minus a negative 3. This is the x value. This is the y value. Right? This equal 2. And then right here, so clearly 3 minus 1 equals 2. So that's why this is the answer. So you see, you don't have to waste time and solve it. Right? You have to be smart. Use a process of elimination. Sometimes elimination method is quicker. Right? So you realize that all the points will work on that. You're just trying to find the points that will work on this. And I simplify this by writing it as y minus x equals 2. So I'm looking for the points where the y value minus the x value is equal to 2. And I'm using a process of elimination. And that is it. All right, and put a different color in between here. That is it. All right. Next question. The point of intersection of a line with the same thing. Again, you say another question, same thing. Another question, same thing. Because these are 3 and 4. 3 squared and 4 squared is always going to give you 25. Whether they're positive or negative. Gonna give you 25. Because remember, negative 3 squared is the same as positive 3 squared. Negative 4 squared is the same as positive 4 squared. So all the points work on this equation. I'm not going to waste time and solve them simultaneously. All I need to do now is see which points the sum of x and y is 7. That's what I want. I'm using this point to investigate what I'm doing. I'm going to test and see which point the x plus y is equal to 7. Test and see which one works for that. Don't make sense to focus on that. Test and see where the sum of x and y is 7. Not this. Because this and this is negative 7. Good? Negative 7. There must be we have two positive values, you know? Not this. Because this and this is 1. Not this. Because this and this is negative 1. So it has to be these two. 3 and 4 is 7, and 7 and 3 is 4. Must be that one. Right? So I write it out. 3 plus 4 is 7. Put a point here. And the other point, 4 plus 3 is still 7. Right? So, you see some of these questions we spend a lot of time doing sometimes. And they can be done easily by using a process of elimination. Right? So you have to be smart. So that approach might go and try to solve this simultaneously and waste a lot of time. Maybe I do some questions that could be done quicker too. But that's how it is. But the ones that are obvious, don't make no sense. We waste time on them. The long method. And the answer is there on the paper that can help you. The answers on the paper. Remember that at all times. The answers are there just for them. So if you can just use the process of elimination, get your answer, you do it. All right? They will come up to vectors now. Reach vectors yet? No, we have one more line, one more circle. This one says a line passes through the center of this circle, and the center point is going to be 3, negative 2, right? 3, negative 2. It says, and it's parallel to the x-axis. It's parallel to the x-axis. So the x-axis is a line y equals 0. So the parallel, if the x-axis is y equals 0, the line that you want is y equals some number. Right? It's parallel to the x-axis. So your answer that you want, the line that you want, is y equals some value b. And it's the y value at the point. It's going to be this one. Y at y. It's going to pass to the point. It's going to pass to the point. All right. So it's y equals b through. That passes through the center point. It said the line passing through the center of this and parallel to the x-axis. He said the x-axis is y equals 0 right now. So the parallel line will be y equals b. Right? This is the line that we want. We want this line, a line of this form. We want a line of this form, right? Y equals b. Because the parallel to the x-axis is y equals 0. A line that is parallel to the x-axis is from y equals b. But it passes through the point, the center point, which is 3, negative 2. So it has the same y value as that point. Because every point on this line is going to have the same y value. So the center point of a y value of negative 2, then the line that it's talking about is y equals negative 2. So i.e. y equals negative 2. If I sketch it, just for you to see, get a visual of it. I like this question. Remember, I don't see any other like this, right? If I sketch it and put a circle, and the point is 3, negative 2, and the line that we want goes like this. It's a line y equals b, you know. Then what will happen is that it will cross the y-axis, through the y-axis and the x-axis. Let's say the y-axis is here, and x-axis is here. Well, it's negative 2, so the y-axis, x-axis is going to be above it, right? Let me shift this down. Let me shift down. The x-axis is going to be above the center point. So let's say the center point, let's say this is the y-axis, and let's say this is the x-axis right here. This is the y-axis. This is the origin. Then right here says negative 2 on the y-axis, you know. This is negative 2 on the y-axis. So our horizontal line passing through negative 2 on the y-axis is y equals negative 2. Negative 2. Right, just over 3. But the point is 3, -2. Then right here says 3 on the x-axis and right here says -2. Right? But generally speaking, if you want a horizontal line passing through a point, then that horizontal line will be an equation y equals the y value at that point. If I wanted a line this way, then it will be x equals the x value at this point, which will be 3. If the question is parallel to the y-axis instead, then the line will be x equals 3 because it passed through 3, -2. All right, so that is that. So in fact, let me leave this line on it. I'll leave that line on it just for to show this line. If I wanted this line instead, I'm show it in a different color. I'm show it black. If I wanted the vertical line instead, that would be x equals 3. If they said the line was parallel to the y-axis, then it would be that line I'm talking about. Pass to the center point right there. All right, it will be x equals that x value, vertical line. All right, so the answer is y equals -2. The horizontal line that they want. I like this question. I like it. I like it. We call for questions like these guys. Next time I might say y-axis. All right, so it will be y, it will be x equal the x value at the point. All right, let's continue. Vectors now. Oh, so we're taking a break, right? Taking a break and then we'll come to the vectors. We can take 10 minutes break. Let's do a 10 minutes break and then we start back with the vectors. Let's do a 10 minutes break. I want to finish kind of early today and I don't want to go too late. I know people have exams tomorrow and stuff. All right, 10 minutes break. We're going to start back with the vectors. So we have vectors and trigonometry. I remember I said I might want to do 1 or 2 questions on specimen paper. The statistics, probability, and the motion of straight line. It would be nice to do those questions. So let us go. All right, 10 minutes break, guys. All right, guys. So let's go again. So going on to vectors now. So it's vectors and trigonometry. All right. So let's go. All right. So this first vectors question here says vector A is given as this. And I want us to find the unit vector that is parallel to A. So the unit vector is a vector that has a modulus of 1 unit. So if you want a unit vector in the same direction as that, then that unit vector, which is with A hat, is 1 over the modulus of A multiplied by A itself. All right. So we divide the vector by its modulus. What is the modulus of A? It's going to be 13, you know, because the modulus of A this time. Now we're going to write it down here. Can write it down here. So the unit vector becomes 1 over the modulus. Modulus of the square root is square root of 5 squared plus 12 squared. So the square root of 5 squared plus 12 squared. That gives us the modulus, which is the length of the vector. And multiply by the vector itself, which is 5i plus 12j. That's a 5, 12, 13 triangle. So this is 13. Right? This is 25 and 144. 25 and 144, 169. Square root of 169 is 13. So this becomes 1 over 13 times 5i plus 12j. Very easy question. 12j. All right, so you're looking for that one, which is right here. All right, nice and easy. That's the unit vector. All right, next question. This one gives us two vectors. And it tells us that they are parallel, and we must therefore find the lambda. Now, if they are parallel, then one is a multiple of the next. Therefore, you can multiply one by a constant to get by a multiplying constant to get the other. So if I look at these two vectors and I want them to become equal, I would have to basically multiply this one by 5 for that to become 5j as well. So if I multiply this one by 5, if they are parallel, and I multiply this one by 5, it will become equal to that one. So I'm going to take the A and I'm going to multiply by 5. I'm going to take this one and I'm going to multiply it by 5 for it to become equal to the next one. So I'm going to get 5A equals 25i plus 5j. Right? And then now I'm going to compare that with the B, which is lambda I plus 5j. What does that mean? Is that the 5a is equal to b because they are parallel. And so therefore, these I components equal. So you can say that the lambda equals 25. Right? If the 5a equals b. Let's write it down here. So the b is going to be equal to 5a. And so if we equate the coefficients, the lambda, or equate the component, the lambda is going to be equal to 25. But one is a multiple of the next, so they're parallel. When two vectors are parallel, one can be expressed as a multiple of the next. And it's just simply try to make these two equal by multiplying this one by 5, right? So simple as that. So this is equal to 25. Right? Next one. Two vectors are parallel if. So this question, I think this question was kind of ambiguous. All right. They are parallel if they have the same direction. They do have to have the same magnitude. This one says they're parallel. This one says, which of these is correct, right? Different directions. So once the direction is different, no. So because this is saying different direction, the answer is no for this one. They're not parallel. This one is saying same magnitude and same direction. No, when they have the same magnitude and same direction, these are equal vectors. But equal vectors are also parallel. And that's the problem with this question, because these two will be parallel as well, because they are equal. If they are equal, they have the same magnitude and same direction. If they have the same direction, they are parallel. If I look down here, I say they are parallel and different directions. So here it says different direction again. So once the direction is different, you know that's a no-no. If you look at this last one now, it said they have different magnitude and are in the same direction. Now, this, but because they have the same direction, means that they are parallel. So this is a yes. But this will be a yes to as well, you know, technically, you know. But because this goes further, this one goes further than just parallel vectors. In fact, they go all the way up to equal vectors. I have to select this one as my answer for the parallel vectors thing. Right? They have different magnitude, different magnitude, but are in the same direction. But technically, these two parallel as well. So I'm going to write parallel as well. I'm writing right here. These are parallel as well. Parallel as well. So this is not a good question. But if I have to select an answer, I have to select that one. But this one passed the stage of just being parallel. That's gotten up to being equal by virtue of having the same magnitude. So if I select an answer, I would select B, because it stops at being just parallel by having different magnitude. All right, so let's see. There was another question here, but this one talk about equal now. Same thing, them equal, them have the same magnitude and same direction. So this one is clearly just this answer. Anything apart from this is wrong. Same magnitude, different direction. Them equal, them have to be same magnitude and same direction. This make it wrong. Underline what makes them wrong again. So this different direction, red. Different direction causes this one to be not correct. Different direction, not correct. Different magnitude and same direction. Well, this don't know because they have different magnitude, they're not equal. This one caused them to be wrong this time. Because for them to be equal, they have to have the same magnitude and same direction, which is what we have ticked here. All right, that is that. So look at these two questions, very similar, but you still look at nuance there. All right. All right, hold on a second. Hold on a second. All right. Next question. This question says, Bennett for C and D refer to this. So they give us these three vectors, X, Y, and Z. It says, but to calculate the value of the scalar product. All right. Now, I'm going to write X, Y, and Z in a column vector form. So I'm going to write the X as 3, -8. This one. I'm going to write the Y as 6, 12. That's this one. I'm going to shift these over and write the Z as well. So the Z is 6, 4M. It's sometimes easier to see the values when they're written like that. You say, what is the scalar product of X and Y? So we're doing the scalar product between these two. So the X dot Y is going to be equal to, you multiply these two I components, which is 3 times 6, plus you multiply these two J components, which is -8. -8 times 12. Right? I work that out. Now I just work out. Hold on a second, guys. Someone call me. I'm gonna send this message. All right. All right. So let's work this out now. This works out to be negative, and that's 18. That's -78. All right. That's the answer right there. All right, negative 78. All right, so that is that. Next one down here now says the vector y and z are perpendicular. What is m? Now, if they are perpendicular, it means that the scalar product is 0. When they are perpendicular, this means that the scalar product y dot z is equal to 0. So the scalar product between these two now must be 0. All right. So it means then, if we're using this calculation, it means that the product of these two, 6 times 6, and 12 times 4m is equal to 0. All right. I was solving this for m. So if we're solving this for m, this is 36. I just want to do the easy way, you know. Can divide through. This is 36 plus 12 times 4m equals 0. I'm going to divide through by 12 first and get 3 plus 4m equals 0. Transpose the 3 and divide by the 4. So the m equals negative 3 over 4. This is the answer. That is it. The key thing is that it's a perpendicular, the scalar product is there. I'll put this in red right here. And that is the key thing. If we don't change the size, I'll be right. All right, that's it. Scalar product is 0 and they are perpendicular. And that's what we did right here. That's what we did right here. All right, that finishes that one. Next one. They give us these two vectors and I want to calculate the vector AB. So AB is actually equal to, O times the last, which is OB, minus O times the first, which is OA. That's a quick way to calculate. OB minus OA, last minus first. O times the last, B is the last, minus O times the first, A is the first. So basically doing this one minus this one. Simple as that. So it becomes equal to 45 minus negative 1725. So to show this, I could just subtract them across here, but no problem. So minus is a plus. So it becomes 4 plus 17, which is 21. This is the only answer with that 21. And then 5 minus 25 is negative 20. Yeah. So the answer is this last one down here. 101 with a 21 there. All right, nice and easy. Next question right here. It says, quotient vector of 2 points A and B relative to an origin O are these. These are your 2 points, right? It says the modulus of AB and the angle that AB makes with X direction relative respectively are the modulus. So the first we need to find is AB. Let me stop here so now. I don't have any space, right? Right up here. So the AB is OB minus OA again. The AB is OB minus OA. I'm just going to subtract them. So it's this one minus this one, right? So it's 8 minus 3, which is 5. And 5 minus 0, which is still 5. All right? So that is it. So what is the modulus? Let's write the modulus beside it. So based on that, now let's say the modulus in here. So the modulus of AB, zoom it up. The modulus of AB man, press the wrong thing, guys. Sorry about that. So the modulus of AB becomes equal to the square root of 5 squared plus 5 squared. So these are the 2 components, right? That's the length of the vector, which is root 50, 25 and 25. is 50, so it becomes square root of 50. So that's a modulus, right? So it's either this one or this one. What is the angle now? And the angle they're talking about is the angle that it makes with the x direction. What does that mean? Sure, that means in a sketch. So it is like you have the vector AB. Let me sketch it for you. So this is the vector AB. And what they're saying is that as component 5, 5. This 5 means 5 this way, and this 5 means 5 this way. So that is your 5 and your 5. So the vector is 5, 5. This is 90 degrees. That's why to get the modulus, to use basically Pythagoras' theorem to get the length of this line. The modulus is the length of that line. So square root of this square plus this square. So this angle that they're talking about now, angle that it makes with the x direction, the x-axis. And because the x-axis would be this way, y-axis this way. So the angle that it makes with the x-axis is this angle right here. I'll bring it up close and show you. The angle that they're talking about is this angle right here. Let's put it in a different color. Talking about this angle right here. That is the angle that I'm talking about. So that's a right angle triangle. To get that angle, we could say tan theta equals opposite over adjacent, which is equal to 1. Tan theta equals 1. So the angle theta will be tan to the minus 1 of 1, which everybody should know is 45 degrees. Because the tan of 45 degrees is 1. It's good to know those angles in it. It's good to know the trig ratios of 30 degrees are 0, 30, 45, 60, and 90. So you should know that if tan of the angle is 1, then the angle is 45 degrees. So this is the angle the question talking about. The angle that it makes with the x-axis. So the angle is actually 45 degrees. So I place a solution up there. So this is the correct one, 45 degrees. This is not correct. All right, so those two are the ones that are correct. So my answer is here. I'll get that first by calculating the vector AB. First thing we have to do is calculate the vector AB. Then we could see the modulus and see the angle. All right, so that is that. Next question. Gives us these three vectors. It says triangle OAB have vertices given as these. So these are position vectors for the vertices. So this one is OA and this one is OB. Right? Let's write them up. So it means that, oh, and they tell us now, given that the angle at O, this means the angle at O, is 90 degrees. So let's sketch it. What is the value of A? So once I say 90 degrees, you know it's a scalar product equals 0 between two vectors. So basically what it is that you have the vector negative 3A like this. You have the vector 6, 2, maybe like that. So this out here is B, up here is A, right here is O. And what they're saying is that this angle inside here is 90. Put it in red. This angle up here is 90. Because pi by 2 is 90 degrees. That's what we need to know, Pi by 2 is 90 degrees. So the angle between them is 90 degrees. So if the angle between them is 90 degrees, then the scalar product is 0. So if I put on the vectors, this vector is OB, and this vector is OA. And they are both diverging from O. So because the angle here is 90 degrees, then the scalar product is 0, 90 degrees. So because the angle between them is 90 degrees, it means that the scalar product is 0. So what you know is that OA dot OB, put a different color, all right, right here. Shift this over. Let's shift this over here. Do the work in a different color here. So OA dot OB is equal to 0 because the scalar product is 0 because the vectors are perpendicular to one another. All right, so the scalar product between these two vectors equals 0. What's the scalar product? These two, multiply them, says minus 3 times 6. And then multiply these two, which is 2a, 2 times a, 2 times a is equal to 0. And that's what you're solving now. This is negative 18, you know. Goes over it to become positive 18 and divide by 2. So we can write 2a equals 18. And so a equals 9. So the answer is this 9 right here. 9. That's it. Easy question. Next one says, portion vector of A and B are these two. And what is the acute angle between them? So it's like you have the two divergent vectors from O. Right? Again, OA and OB says 3, negative 1, 2, 5. So like you have one going up that way and one going that way. This is O. This is A again. Right here is B. Trying to find this angle between them. Right here. This angle. So when you scalar product, the OA diverging and the OB diverging. Two divergent vectors. But the angle between two vectors is a cos to the minus 1 of the scalar product over the modulus product. Right? So let's call this one A and call this one B. That's for simplicity. So the angle between them, theta, is cos to the minus 1 of the scalar product A dot B over the modulus product. Modulus of A times the modulus of B. That's how you calculate it. And this is these two vectors we're talking about. Let's call this one A. Let's call this one B. Right? So this one is the same OA, and this one is the same OB. I must call it AM. Right? So you basically want to calculate and see which one of these matches, right? So doing the scalar product first, it becomes equal to cos to the minus 1 of. The scalar product now is 2 times 3, which is 6, and 5 times minus 1, which is negative 5. So you're getting a 1 on the numerator there, over modulus product. Now let me shift this over a bit so I have a bit more space to write. So this up here is a scalar product so far. Now the modulus product now, the modulus of this A first is square root of 2 squared plus 5 squared, square root, zoom it up, square root of 2 squared plus 5 squared times the square root. The other one is what? 3 negative 1. We don't have to use negative when you do the modulus, so it's 3 1. Right? So it's 3 squared plus 1 squared. That's what you're calculating. Right? That's what we're calculating right there. And then let's work it out. So it becomes cos to the minus 1. This becomes a 1 up here over. This is now 29. 25 and 4 is 29. Root 29 times root. This becomes 10. 3 squared is 9 and 1 make 10. And then you can consolidate this and put as root 29 or root 290. So it's cos to the minus 1 of 1 over root 290. You have to work it out all the way down, you know. To see what it is from right here. Or even from right here. But you know, just to show the work to completion. So the answer is A. So this question could have been on a paper. That is it. So it's a typical scalar product to find angle, right? That finishes that part. Let's go over here and do this one. It says portion vector of P and P relative to origin O is given as this. So this is a vector 5, 2, and the portion vector of Q is this one, negative 4, 10. Which of the following statement is true? All right. So are they parallel? If they are parallel, one is a multiple of the next. Which of the following statement is true? Are they perpendicular? To say if they're perpendicular, I'm going to say no to this first. Because if they were parallel, then one would be a multiple of the next. And that is not the case, because if I multiply this one by 5 to make it become equal to this the fact that this component negative and this one positive, they cannot be parallel. So they're not parallel. I'm not going to test this yet. I'm going to jump and test perpendicular first. So they are perpendicular, the scalar product is 0. All right, so let's test that. So I'm going to test perpendicular. So perpendicular, put the question mark, I'm testing if they are perpendicular. All right, let's work it out. So the scalar product, which is P dot Q. If it come out to be 0, then yes, they are perpendicular. What's the scalar product? It's a 5 times the negative 10. 5 times the negative 4, sorry, this times this, right? 5 times negative 4. 5 times negative 4 and 2 times 10. 2 times 10. And this work out to be 0 because this is negative 20, you know. It's work out to be 0. So yes, they are perpendicular. Answer is yes. Because it equals 0. So the answer is C. And that's it. But okay with that? But okay?
Yes, sir.
All right. Next question. With respect to an origin O, A has these coordinates. And I say, what is 3OA? You know, first you have to know that if these are the coordinates, that means that the vector OA will have the same values as the coordinates, 3, negative 2. And what they want is 3OA. So let's basically multiplying this by 3 to get 3OA. So it means that 3OA is 3 times this, which is 9, negative 6. Easy question. So the answer is 9, negative 6 right here. Free question, this one. I can give away. Right? And you can't put this as an answer, no, guys. All right, if they even gave 9, negative 6 right here, we could not put this right here. The question asks for coordinates in it, asks for the vector. And the vector must be written as a column vector like this. All right, so you can't put that. Even if this was a negative 6 right here, it's a vector that we wanted. All right, so that is that. All right, next question. It says, vectors I and j represent 1 kilometer per hour east and north, respectively. It says a man sails his boat on a lake, such that the velocity is this. The velocity is this. When there is no current. So this is always going when there's no current. If there is a current of 3I, then what is the resultant? You basically have to add the vectors. To get the resultant of 2 vectors, you have to add them. Simple as that. Right? Once you want the resultant, you have to add them. So it becomes negative I plus 2j. That's the first vector of himself. And then the current is also going to act on him. 3I. Current on him is 3I. So the 3I minus I is 2I. So it's going to be equal to 2I plus 2j. So it's going to be 2I plus 2j, which is answer is A right here. So once you want the resultant of vectors, you add the vectors. Simple as that. Next question says, OA is this and OB is that. What is the vector AB? We'll do this question already, you know. This is 21 thing. The same question we did over here. Here, so same values. Same values. Sit there. Same values. We'll repeat 4, 5. We'll repeat. We just did it a while ago. So we can later just copy this across. And just put it down. We just did this a while ago. Let's repeat it on the paper. Accidentally, I guess. All right. Something like that. Never just need to use this and mark this one. I just did it a while ago. Just calculate AB. O time the last minus O time the first. Same question. All right, that's a repeat question. Up here. Then we come to trigonometry now. Voila! Beautiful. So let's fly. Trigonometry kind of longish, right? It's now 230, 130. All right, so we have some time. So we're gonna try and rush through the trigonometry straight. As I said, I want to do 1 or 2 questions on the specimen paper. In particular, the motion of straight line and the probability statistics. All right, but let's do the trigs now. All right, so trig is gonna take us that page, through to that page, through to that page, down here. So we're in 2 full pages. We're going to bit of trigs in the middle here as well. So basically, we're going 2, 1, 2 full pages. We're gonna see that a lot of the questions very similar. And yeah, we'll be able to work more quickly. All right, let's go. Boom, bang, ready. So this question says, sine theta is 5/13 and it is obtuse. Now, obtuse means that you're in the second quadrant of a circle. The angle is greater than 90 and less than 180. So if I were to represent this information on my quadrant diagram like this, it means that my angle is in the second quadrant. So this is my quadrant diagram. I can draw my triangle in the second quadrant over here. Use a red ink. So my triangle is over here now. And the angle theta is actually this angle theta. If I zoom it up, let me go over this line and do the angle. Sure. Go over the angle right here. Right. So if I zoom it up to try to isolate the triangle that I'm working in, right? And I said the tan. Now remember the equivalent angle inside here, so it's alpha right here, alpha. Equivalent to the total angle theta. Sine is opposite over hypotenuse. So it means that my opposite is 5 and my hypotenuse is 13. But that's a positive 5 because my point is up here. Positive y value. The radius is always positive. But this coordinate now is negative. So this is actually negative 12. 5, 12, 13 triangle, meaning that's a right angle. This is actually negative 12. And I want the tan of theta. Tan still equal opposite over adjacent. You know? So the tan of theta is the opposite side, which is 5 over negative 12. Opposite over negative 12. Or you could say, because the angle is in the second quadrant, tan is negative in the second quadrant because it's obtuse. Right? But this theoretically is the way. This diagram is a good way to represent what is happening. So it's 5 over negative 12, which is the same as negative 5 over 12. So this is the answer. We'll use a calculator and do this. No, I couldn't use a calculator and do this because if you try to do sine to the minus 1 of 5 over 30, it's going to just give it the acute angle. Right? It's going to give it the acute angle. No, you could use the acute angle now and know that you want the obtuse angle now. And the 180 minus that acute angle if you want it. Right? But I think, using a quadrant diagram approach is a good way to approach it. Because the angle is obtuse here in the second quadrant. All right, where sine is negative and tan. Sine is positive and tan is negative. Another question here, similar. This question says, the angle is acute this time, and the cos is 3 over 5, and I want to find the sine of 2. Now this calculator can do this, Calculator can do this. Because if I'm using a calculator, because the angle is acute, the calculator is always going to give me acute angle first. So from this, I could say x equals cos to the minus 1 of 3 over 5 on the calculator. And then I put this for my x right here. And then what would happen is that this calculation that I want will be sine of 2 times cos to the minus 1 of 3 over 5. And then I just need to put this in the calculator. Let's see if that will work. I'm showing you how you could use the calculator on a question like that because it is numeric. And I'm going to show you how you work it out otherwise, right? So we'll put that in the calculator. Sine of 2 times 2 bracket cos to the minus 1 of 3 over 5. and I get 0.96 as a fraction. See, I'm getting 24 over 25, you know, which is there. See there? That's the answer. 24 over 25. So the calculator can work that out because it is numeric. They could work it out that way and get the answer. All right, but let's say they didn't give you a values that you could put in a calculator. Then I have to work it out using my trigonometry method, right? So let's see. So remember, guys, when the question is numeric, you can use your calculator to do it. All right, so how do we approach this now? When they give you one trig ratio, it is acute. You draw the triangle to represent that trig ratio. Because this is acute, it will be in the first quadrant. And when it's in the first quadrant, your triangle like this. See, like a circle is like this, you know. Yeah, like that. You're in the first quadrant, right? So I'm drawing my triangle like that. And my angle right here is x. Now, cos is adjacent over hypotenuse. So this is 3 over 5. So we have a 3, 4, 5 triangle here. So this side is actually 4. Good to know those Pythagorean triple. Otherwise, I have to calculate it using Pythagoras' theorem. So this side is equal to 4. So you see, that's another 3, 4, 5. No, this was a 5, 12, 13 up. You need to know these Pythagorean triples. So in any case, now we want the sine of 2x. Now, based on this, I now know that the sine of x is 4 over 5, opposite over hypotenuse. What is the sine of 2x that I want to know? What is the sine of 2x? See here now. Let's go back for a different color now to get the sine of 2x. So this sine of 2x is 2 sine x cos x. That's the identity, you know. When you know your trig identities, these things are very easy. It's very important to know those double angles, but you could get it from a compound angle as well. But that is what it is equal to. So it becomes twice the product of these two things. Right? It becomes 2 times the sine x is 4 over 5 times the cos x is 3 over 5. So you see you get 2 times 4 is 12. 2 times 4 is 8, sorry. 8 times 3 is 24. So you get 24 over 5 times 5 is 25. That's the way to do it by calculation. But you see that the calculator can work it out as well because it is numeric. Right? It's a numeric question with all our values in it. So just bear that in mind. This question, the exact value of this, again, that can go in the calculator. That can go in the calculator. Right? Just put it in the calculator. Right? Sine of 150 over sine of a cos of 150. That's a tan of 150, because sine over cos is tan. But you could put in the calculator as is, right? First, you're going to put the calculator in degrees. I'm going to put a fraction. Sine of 150. Sine of 150 over cos of 150. Let's look at it. See what I get here? Negative root 3 over 3. Now, that is not here, so, you know, because they have a rational number in the denominator. But you should know that if you have negative root 3 over 3, it's the same as 1 over root 3 because I multiplied it by root 3 over root 3. Root 3 times root 3 is 3, cancel this 3. So I get minus 1 over root 3. So it's the same answer. So even though they show me that it will be the negative 1 over root 3. It will be this answer. Good? That is it. So the question is numeric, put it in the calculator and work it out. But maybe what they wanted to do really is to recognize that this is tan first of 150. So this is equal to the tan of 150 degrees. Because tan is sine over cos. Sine over cos is tan. Then 150 is in the second quadrant. So you're basically working in the second quadrant over here, where this angle is 150 degrees. Now the angle inside the triangle here now will be 30 degrees. 30 degrees, because I need 30 degrees to complete this. Complete up to 180. So you're working in this triangle now. Right, so you're finding tan is in the second quadrant. In the second quadrant, so the tan of 150 is equivalent to negative tan of 30 because you're in the second quadrant. So see, you know the tan of 150. Because in the second quadrant, it is negative than the tan of 30. And the tan of 30 should know is 1 over root 3. So it becomes minus 1 over root 3 or root 3 over 3. It could be root 3 over 3 as well. But this is the answer that they have. So that's what we're going to give them. So we can say, or it is root 3 over 3 minus root 3 over 3. But this is the answer though. But I just say, see, calculator can work out. So all this working that I'm doing not necessary. Just drop it in the calculator and go about your business. All right? Once you can put in the calculator, do it. Don't waste time. This one now. I want the cost of 5 pi by 2. Again, you can put that in the calculator. Oh Lord. Put the calculator in radians. Put it in radians. And then put the cost of 5 pi by 12 in your calculator. Cost of fraction 5 pi over 12. Get that? Look at it as a search from teacher right here. So give you this, give you that, give you that. We try to match it. Root 6 minus root 2 plus root 6. This is it. That's what it is. Root 6 minus root 2 and a quarter. That is it. Calculator give you that. You have to get one of those calculators. Well, let's say you don't have the calculator like that. You have to work it out. Right? You have to work it out. I don't want a lot of space. So let me try and squeeze it into place. I'm show you. The first thing you want to do is write that 5 pi by 12 as 2 pi by 12 plus 3 pi by 12. So it's going to become the cos of 2 pi by 12 plus 3 pi by 12. Now this is pi by 6. So it becomes the cos pi by 6 plus this is now pi by 4. So you get it down to the angles that you should know. This is actually 30 degrees and this is 45 degrees, which you should know these things. If they give me the cos of pi by 12 to do, for example, what would I put it as? I'll maybe put it as the cos of 3 pi by 12 minus 2 pi by 12. That's what I would do now. Then to be the cos of pi by 4 minus pi by 6. If they give me pi by 12, that's what I would do. Put as 3 pi by 12 minus 2 pi by 12. 3 minus 2 is 1. So remember this, guys, if they should give you something like that, all right? Pi by 12. But again, you can just drop it in the calculator. But anyway, let's continue. So I have to expand this now. The expansion of cos is cos minus sin. Cos minus sin. So this now will become equal to cos pi by 6, cos pi by 4, because I have a plus in here, I have to put a minus out here. Then sin pi by 6, sin pi by 4. That's the easy way to remember the expansion of a cos compound angle. Cos, sin. If you have a plus here, so you have a minus in between them there. You just have to remember that. Cos, sin. What is the cos? Remember, this is 30 degrees. You know? Cos of 30 degrees is root 3 over 2. Cos of 45 degrees, this is 45 degrees. You have to know these things. Is root 2 over 2. Minus sine of 60 degrees is a half. And the sine of 45 degrees is also root 2 over 2. So this root 3 times root 2 give me root 6 over 4. This is 4. Minus this is root 2 over 4. Then I factorize away the quarter from those. I get a quarter into root 6 minus root 2. That is it. Root 6 minus root 2. So the answer is A, as I said. A quarter. And that is it. So, you know, if you have to work it out, and that's it. But, you know, the beauty about it that the calculator can use, if you have the right calculator. So it's very important that you get one of those calculators that can work with these things. All right? You have to work them out. Question that can be done with a calculator makes sense. And a lot of the tricks questions are like that. They can be done with a calculator. Next one. This one now, they want us to expand this now. All right? And see which one of these is equal to. If you do pure maths, we could use something that we call a factor formula, which is sum of two costs. The sum of two costs is what we call a cost, by the cost of half the sum times the cost of half the difference. So using that knowledge, I know that the answer is this one. All right? That's half the sum of these, and then half the difference of those. Give me that, right? But you don't know that. So I have to expand it out and work it out. So let me do it step back. I don't want that space. I'm going to expand out this one first in red, and then I'm going to expand out this one in blue and add them. Let's do the red one first. When I expand the one in red, it's still cos, sin, but because I have a plus here, I'm going to get a minus between them. So it will become cos, which is cos A, cos B. Since it's a plus, I'm going to get a minus sin A, sin B. That's what I get when I expand this one. When I expand the one in blue, which I have to add to it, I'm adding to it. So it's plus. The one in blue is cos, sin again. But because I have a minus here, I'm going to put a plus in between them. So it's cos A, cos B. I have to now put a plus, sin A, sin B. That's what this one gives me. Then I'm adding everything now. Bam, adding up everything. When I add up everything, these two wipe out each other. And I'm left with two of these. Two of that. This plus this. So it becomes 2 cos A, cos B. So the answer is this one right here. Right? So that's the beauty of knowing your trigger identities, guys. These things become very easy when you know your trigger identities. Remember, the compound angle for cos is cos, sin. Cos, sin. The compound angle for sine is sin, cos, sin. Sin, cos, sin. If you go up any question, we'll see. This one now is a circular measure. So we're going to get some circular measures question in here as well. But let's do them same time, right? So this question says, refers to the protractor, which represents half of a circle. Protractor has a radius of 1.5. So this is a R. So this is the radius right here. So the R equals 1.5. And the angle there at O is 45 degrees. Now this 45 degrees is pi by 4. The 45 degrees is pi by 4 in radians. Pi by 4 in radians. And the question is asking us, what is the arc length? Right? The arc length is r theta. This x is r theta. So this x at the one is r theta when the theta is in degree, is in radians. That's why I write it in radians. If you want, you could do the theta over 360 business, right? If you notice, they give these answers in terms of pi. So we need to get it in radians right here. So the arc length, let's put it in blue. X is equal to r times theta. Now this 1.5, and notice these answers are in fraction form. 1.5 is 2 over 2. This is 2 over 2. Right? So we can write it here. The r equals 2 over 2. R equals 2 over 2. 1.5 is 2 over 2. So this is 2 over 2 for the r. And the angle in radians is pi by 4. So the answer is 3 pi by 8. 3 pi by 8, which is right here. Nice and easy. All right. So let's continue up here. This question now says, size of angle x measured in radians. So they give us in degrees first, and I want x in radians. So we'll find out what it is in degrees first. So initially, the x is 180 minus the sum of these two. 180 degrees minus 110 and the 34. Subtract the sum of them. X equals what? Let's spread that out quickly. That equal to 36, like 36. So looks like 36 to me. Yeah, 36. So this is 36 degrees. All right. And we want it in radians. Now, to get it in radians, to get degrees into radians, right? All you need to do is multiply by pi radians and then divide it by 180 degrees. Because remember, pi is 180. So I'm going to multiply to get in radians. I'm going to multiply by pi to get it in radians. But because pi is equivalent to 180, I'm also dividing by 180. So it's basically almost like I am multiplying by 1, because pi and 180 is the same angle. Right? So basically, I'm dividing this down. Dividing this down. So what is become? This becomes a pi by what? 36 divided 180 divided into 36. Hold on a second, guys. Hello? Hello? Yeah? Yeah, man, I'm in a class. Anyway, I'm in a class and can't leave that. I'm in a class. Yeah. All right, cool. All right, sorry about that, guys. All right, so basically, this is 5 times, right? Listen to this goes 5 times. All right, 5 times. So, because it's 10 times 360, so it's 5 times. So this becomes pi by 5. So the answer is pi by 5, which is A. All right, that is that. Next question. Which are the following formulae used to calculate area of a sector A with a radius R and an arc length L and the angle is Q? So normally we would say theta, but I said Q this time, right? Which formula is correct? So what are the formulae involved? Connecting the A, what are the formulae connecting A, R, L, and Q? Q is theta, remember, Q is a theta, right? All right, what are the formulae? Let's write them out. Formulae connecting them. Well, actually, this one is given. All right, so we know that one already because we know that the area is half R squared theta. Instead of theta, we're going to write Q. That's one. And so this one is correct. That is the original one for A, right? So this one is correct. And then now we know that arc length is equal to R times theta. Again, we're going to write Q for the theta. So RQ. Now, if I observe this, for example, what I realized is that they have eliminated the R from this. So they take the R out of this. And for this one, they have eliminated the theta, the Q. So what we're going to do, we're going to make R the subject of this one first and see how they substitute it here. So from this one, we're going to say that the R is equal to L over Q. And also the Q is equal to L over R. And we're going to look now and see if we make the substitution and put this in red, in a different color. These. Put them in a different color. All right. Didn't change. Let's go again. All right. So we made the substitution for the R here first, right? Right here in this formula. What are we gonna get? Let's test it. So the A would be equal to the R now, substituting for this R, right? it will become L over Q squared times Q over 2. What you find is that this is really L squared, and then now the Q will cancel one of this. So you get L squared over Q over this 2. So we can put the half in front, same way for the over 2. So therefore, so 2 on here, 2 is on there now. So this is correct as well, based on that. So we can mark this as correct. And then in this third case, that is substitute for the Q. So if we start with this again, it's original formula here, and substitute for the Q, then the A would be equal to R squared. Then we substitute for the Q, and the Q is L over R. And we're putting that over 2. And if we do that now, then this R will cancel one of this, and so it will become RL over 2. This is what this is. LR over 2, same thing. So this third one is also correct. So you realize that all 3 are correct. Okay, if we make those substitutions, all 3 are correct. So that is it. A nice question, I like it. So all 3 correct, guys. All 3 correct. So the answer is this one. All right, this question now says, figure MON below shows a quarter circle of radius 4. What is the perimeter? So if it's a quarter circle, means that right here is 90 degrees. But in radians, this is pi by 2. Pi by 2. I know that I need it because these answers are in terms of pi. The radius is 4, so here is 4, and here is 4. And then this side now is r theta. This side is r theta. The theta is pi by 4, so it is really 4 times pi by 4. 4 times pi by 2, sorry. R theta, that's what it becomes, which becomes 2 pi. So the perimeter then, let's call the perimeter P. It becomes 4 plus 4 plus 2 pi. The arc length, 2 pi. So it is 8 plus 2 pi. I don't say that. I say 8 plus pi. But this one is a factor. So if we factorize the 2, out of this, we're going to get the pi. Out of this, we're going to get the 4. So the answer is the last one. That's it. All right, nice and easy. Let's continue. All right, this one is a similar question to what we did before. This is clearly 160. So this is clearly 20, right? So these 2 are up to 160. These 2 are up to 160, obviously, right? These 2 are up to 160. All right, that's 160 degrees. So therefore, this one must be 20 degrees. The total angle is 180. All right, that must be 20 degrees because these 2 are up to 160. So you want 20 degrees in radians. So again, 20 degrees. Let's go for the blue. I want to convert it to radians and multiply it by pi first. I want it in radians. And you divide by what pi is equivalent to. Pi is equivalent to 108. So 2 into this goes 9 times, you know. So this is just basically pi over 9. The answer is right here, pi over 9. B. That is the answer. All right, let's continue. Good. We'll come to the sine graph. All right, so let's talk about this now. Sine 2x, sine of 2x. Now, a simple way to know the sine of 2x is that it has 2 full cycles between 0 and 2 pi. Sine x, so this is sine x, you know. No, this is not sine x. I see a 2 right here, so that's the amplitude. Let me see if I can find sine x. Sine x is this one. So let's look at this one. This one is actually sine x, you know. I have one full sine graph, one full sine cycle between 0 and 2 pi. So this is just sine x, and the amplitude is 1. This is sine x. So how would sine 2x be? Sine 2x would have two full cycles between 0 and 2 pi. So I'm just putting it on this for reference. So sine 2x would basically go like this. You have one full cycle up to pi and a second full cycle up to 2 pi. This would be sine 2x. Two full cycles, one, and then a second one, two. Two full cycles between 0 and 2 pi is sine 2x, sine 2x. So therefore, sine 2x, we can say it has one full cycle up to pi. If you look on right, yes, has one full cycle up to pi. Sine 2x has one full cycle up to pi, which is what does that mean in the first one up here. You have one full cycle up to pi. So this is the answer for sine 2x in this type. This is sine 2x. This one. What would this one be? This is a full sine graph, you know. But the thing is that the magnitude of 2. So this one is actually 2 sine x. The sine x is a regular graph, but you're multiplying the overall y value by 2. So this is a sine 2 sine x graph because of the amplitude of 2. What is this one? This one, to get it out to the full thing, this is actually sine 4x, you know, this. Because you have, this is down to pi by 2, right? So if you extend this graph, extend it, then you have pi out here, so, right, halfway. And then you have another, this is pi by 2, you have pi, then you have 3 pi by 2, and then you have 2 pi, 3 pi by, then you have 2 pi, all the way up here. So if you have one full cycle between 0 and pi by 2, you're going to have another one between 0 and pi. You're going to have another one between 0 and 3 pi by 2. Then you have another one up to 2 pi. So this one is actually sine of 4x, you know, 4 full cycles between 0 and 2 pi. Why is that? Because you have a full cycle up to pi by 2, which is a quarter of the way to 2 pi. So this graph is actually sine of 4 pi. That's what this is, this one. 4x, sine of 4x, I mean. That's what that one is, sine of 4x. And this one down here, as we said, this one down here is just sine x. Because you have a full sine graph between 0 and 2 pi. So this is a regular sine x graph. This is sine x. So you can look at that. All right. That's it. Let's continue. We'll come to this one over here now, which is asking us for the sine x graph. Sine x graph is a regular sine x graph. Amplitude of 1, and go from one single cycle up to 2 pi. Must start at 0 because the sine of 0 is 0. So this one can be sine by start at 1. Cos is one that starts at 1. If this one is actually cos 2x, you know, because you have 2 full cos cycle. See here? This is one cos cycle here, so this is one cos cycle. The cos graph starts at 1. This is the second cos cycle between 0 and 2 pi. So this graph is actually a graph of cos 2x. 2 full cycles between 0 and 2 pi, cos 2x. This one is cos x because you have one cos cycle between 0 and 2 pi. So it is a regular cos x. It starts up at 1. So this is a regular cos x graph. This one, you have half of a cycle, half of a cos cycle between 0 and 2 pi. Because the other half would go like that, you know. So you only have half of a cos graph between 0 and 2 pi. So this one is cos half x. You only have half of a cos graph between 0 and 2 pi. So that is cos of half x. This one is a sine graph. This one is sine x. Sine x graph. You have a full sine graph. Remember, the sine graph starts at 0. Because the sine of 0 is 0. Remember, you know, the cos of 0 is 1. So it starts at 1. So this is a sine graph on it. It's a full sine graph between 0 and 2 pi. So the answer for this question, the one is sine x graph, this is it down here. It's the only one that passes through the origin, so it has to be the sine graph. All of them on this diagram. That is it. See there? They give us a bunch of cos graph and give us just the one sine graph alone. And also sine x. That is it. You have to know these graphs, guys. All right, next question down here. You want the cos of half x. So just the one a while ago. It means that you have half of the cos graph between 0 and 2 pi. This is not none of them. I don't come below the axis. All right. This one is a sine graph. You see, pass at 0, and it's half of it up to 2 pi. And the other half of it will go like this. So it's half of a cos graph. So this is actually the sine graph. So this is actually the sine of half x. This one right here. This one passed through the origin as well. It looked like it will continue with the sine graph. This one more sine graph as it passed through the origin. So it cannot be it either. So you have to X out this. X out that. But the answer really is this one, guys. Right? Half of a cos graph between 0 and 2 pi. And the other half will go like that. So this is sine of half x right here. This is not sine, cos. Cos of half x. So this is the answer for this question. Half of a cos graph says cos half x. Half of the cos graph between 0 and 2 pi. Cos half x. All right, next question over here. Similar stuff. What do you want a cos of 2x? So you want a cos graph, and you want 2 full cycles between 0 and 2 pi. This is it, you know. This is it. That's it here. You have one cos graph up here. That's one cycle. And you have a second cycle up to 2 pi. Between 0 and 2 pi, you have 2 full cycles. So that is cos 2x. So this is cos 2x. This one is cos 2x. Which is what I want. So we can circle this. So let's say they give the same graphs and ask for different things, right? This one is what? This is a straight full cos x graph. That's at 1 and it's full cycle. That you go down and go back up, right? This is a regular cos x graph. This one. This is cos x. This one is half cos half x again. This is cos half of a graph between 0 and 2 pi. This is a sin x graph. This is sin x. See, start at 0, make a full cycle out to 2 pi. So this is a sin x. They don't want any of these. They only want the first one, cos 2x. But the same graph they gave when they asked the question up here, a sin x. Same graph they gave, and same 4 graphs. And then, but they asked for sin x. And now they give the same 4 graphs again, and this time they ask for cos 2x, which is the first. All right, let's continue. This one, which graph is this? All right, let's analyze this one now. So you really need to just see what happened up to 2 pi, right? And getting a full sine graph up to 2 pi. You know that's a sin x. So then the amplitude is 2. So therefore it becomes 2 sin x. Just need to study right here. What happens up to pi, up to 2 pi. The rest of it will continue forever, and no matter what happens after that. Just need to study what happens up to 2 pi. And you have a full sine graph of the 2 pi. But the amplitude is 2. Whatever is I multiply by 2, they put 2 in front. So it's 2 sin x. That graph is 2 sin x. If it was sin 2x, then what would that mean? That you'd have 2 cycles. You'd have 2 cycles. Like so. 1, 2. Right? You'd have 2 cycles. 1, 2. If it was sin 2x. And because that 2, that blue one that I just drew, this blue one that I just drew will be 2 sin 2x. And the amplitude will be 2. And then there are 2 cycles between 0 and 2 pi. That blue one. 2 cycles, 1, 2. All right? but they don't want any of that. So the answer is 2 sin x right here. 2 sin x right here. Y equals 2 sin x. All right, everybody paying attention and getting it. Question break, everybody good? Everybody okay? Finishing off with the tricks.
Yes.
sir.
All right. The video is online, so you can always go back and watch it if you in clarity, you need to look back at anything. It's on my channel online, so you can go and watch it there. This one, the one sine 2x. Again, you must have 2 full cycles between 0 and 2 pi. 2 full cycles between 0 and 2 pi. So this one is a regular sine x. This one is sine x. Let's write them on what they are. This one is a normal sine x graph. This one, you have half of a cycle between 0 and 2 pi, and the amplitude is 2. So this one is 2, because the amplitude is 2. Sine was half of a cycle, but the other cycle go like that. So it's half of a cycle between 0 and 2 pi. So it becomes sine of half x. That's what that graph is. Down here now. So this one now you have 2 full sine graph. Starting at 0, you have 1 sine graph up to pi. And you have a second one up to 2 pi. And the amplitude is 1. So therefore, this one is sine 2x is the one that I want, right? Sine 2x. So this is the one that I want right here. Let's mark it. Let's mark it, the one that I want. This is the one that I want to see. Let's see what the last one is. So this one now is a sine graph again. Go up to 2 pi. How many cycles are there? 1 up to here, so the different color for the second one. 2 up to there, so a different color for the third one. Right again. 3 up to here, so 3 cycles, that's a final. And then you have a 4th cycle. 4. So you have 4 cycles up to 4 pi. So this is actually sine 4x, That's what that graph is, sine 4x. 4 cycles between 0 and 2 pi. 4 sine cycles. So this is sine 4x. You have 4 cycles. 2 pi. 1, 2, 3, 4. 2 red and 2 blue. Between 0 and 2 pi. Between 0 and 2 pi. And the amplitude is 1. You see, this amplitude was, for example, 2 and 2. You put a 2 in front right there, so. And double in the y values. But the amplitude is just 1. They don't put anything in front. That's it. Hope you understand now, guys. The graph is very easy, right? We have to know the basic sine graph and the basic cos graph first. Then you can figure out what they are. Yes, I know I'm explaining it. That finishes the graphs. We're going to go into some other tricks now. All right, let's go. The smallest positive angle for which this equals 0. So if you look at this equation, like we're trying to solve this, right? So if I transpose a cos, I'm going to get sine theta equals cos theta. Now, everybody must know that if sine theta equals cos theta, then the angle is 45 degrees. It's like a must know, Sine of 45 degrees and a cos of 45 degrees is the same. The angle has to be 45 degrees. But I want it in radians. That is pi by 4. That's it, Or if you want to calculate it, then what you have to do with this equation, divide it through by cos. So if you have sine theta minus cos theta equals 0, because it equals 0, you can divide through by cos. So if I divide through by cos theta to form tan, divide through by cos theta. If I divide through by cos theta, then what will happen is that this will become tan, because sine over cos is tan. Minus divide cos by cos, it becomes 1 equals 0. transpose the 1, I will get tan theta equals 1. And if tan theta equals 1, again, the angle must be 45 degrees. Theta is tan to the minus 1 of 1, which is 45 degrees or pi by 4. But why not just know this? If sine equals cos, the angle is 45 degrees. Right? So the angle that they are equal, 45 degrees. All right, so the answer is pi by 4 right here. Easy question. Easy question, really. All right, let's continue. Number this one. So again, you're going between pi and 2 pi, right? So they don't want the first two quadrants. So if I were to draw the quadrant diagram, first for this, it would be that cos theta, we'll zoom it up. It would be that cos theta initially is root 3 over 2. So I know that I'm dealing with 30 degrees, because the cos of 30 degrees is root 3 over 2, which is pi by 6. Right? But I don't want the first quadrant, because I only want angle between pi and 2 pi. So if I were to come to boom and draw my quadrant diagram, first I want where cos is positive. Cos is positive here and here. But this question is Xing out the first two quadrants. They don't want these two quadrants. So I'm crossing them out. My answer must be in only these two. And the only one that I'm valid on this now is the one over here. Let me mark about these two quadrants in red. These will be my two quadrants normally. But the restriction is leading me to just here alone. Now in this quadrant, my angle is always, theta is always 2 pi minus my principal acute angle. How do I get my principal acute angle? It's cos to the minus 1 of this, root 3 over 2, which everybody should know is 30 degrees or pi by 6. So to get the angle that I want, I have to do 2 pi minus pi by 6. So my theta down here now that I want is 2 pi minus pi by 6. Now this is same as 12 over 6. You know? 12 pi over 6 minus pi by 6, which is 11 pi by 6. And that is it. 11 pi by 6. This is angle. If in the exam, I want to know which are these correct. You could plug them in there now and see which are them give me the root 3 now. Plug in the angle in there and see which one of them give you root 3. Try that one here first. You can work it out. Then you try that one here. And you try that one here. Just put the angles in there. The answer is on the paper. Right? So the question again is a numeric question. So you could just plug the angles in the equation that they give you and see which one of them give you the root 3. I put it in this one and see which one of them give you root 3 over 2 in the calculator. Rather than do all of this work. Might be easier. Maybe they'll get the answer already. You just plug in the first value there and get it and you don't. That's just it work. And that will be the answer. Right? But this is how you would work it out. If you have to show working or a way that it would work out. All right, next one. It says the smallest positive angle within the range 0 to 2 pi, which satisfies this equation. No, it is already factorized for us. So it's already factorized for us, right? For the blue. Like you're ready to solve now, right? So this factor would tell us that cos theta equals half. And this factor would give us that cos theta equals 2. But remember, as shown on the graphs, cos by itself is oscillating between 1 and negative 1, same as the sine. So the sine and cos of an angle cannot be outside of 1 and negative 1. So this is not valid. Not valid. Because cos of an angle cannot be less than 1. Cannot be more than 1, right? And cannot be less than -1, right? Has to be some fractional value. Remember, cos of an angle is a fraction of the hypotenuse, Because cos is equal adjacent over hypotenuse, And the hypotenuse is the longest side in the triangle. The adjacent is always shorter. So the adjacent over the hypotenuse should always be a fraction. The most it can be is 1. Because no side in a right angle triangle can be longer than the hypotenuse. It cannot be equal to it. It can be longer. Right? So the cos of an angle cannot be more than 1. So this is not valid. So only this one is valid. And if that one is valid, then the angle is 60 degrees. And the cos of 60 degrees is a half. You just have to know these things. Or if you like, you can do cos to the -1/2. Since I want the smallest positive angle, equal the theta is cos to the -1/2. You don't need the quadrant there this time because you're going to get the smallest angle in the first quadrant anyway. You're going to get pi by 6. Pi by 3, 60 degrees, pi by 3. Pi by 3, which is 60 degrees, right? It is 60 degrees half. Cos of 60 degrees is a half. So the answer is pi by 3 right there. So I'm actually taking longer than needed to these questions, They really can be done really very quickly. I'm just trying to explain stuff, right? Next one. This one says sine of this equals the cos of that. Now here we're going to use complementary angles. Because the cos of x is always equal to the sine of 90 minus x. I'm going to rewrite this equation down here. I'm going to put back this side as it is and write the sine of x plus 20 degrees equal. Now the cos of x can be written as the sine of 90 degrees minus x. We can replace the cos of x with that because of complementary angles. The cos of an angle is equal to the sine of 90 minus that angle. Similarly, the sine of an angle is equal to the cos of 90 minus that angle. Now, since the sine of this is equal to the sine of this, it therefore means that these two angles equal. This must equal that. And like we divide by the sine, just reasoning. If the sine of an angle equal the sine of another angle, then the two angles must equal. So we can draw the conclusion and say x plus 20 must be equal to 90 degrees minus x. And we're solving that. Here over this x over here, so I add it to that one, get 2x. Here over this 20 over here and subtract it from the 90 and get 70 degrees. And therefore the x is 35 degrees. And that is it. 35 degrees is the answer right here. That is it. All right. Remember that question, guys. Complementary angles. The cos of x is the same as the sine of 90 minus x. All right. That is it. Another way to do it would be to expand this out, but then you can use a calculator. Right? But you don't need to do all of that. No, if you expand it out, you're not getting anywhere really. You wouldn't get anywhere. It could work still, but it's too much work. You don't need to do all of that. All right. This one, no. Sine of 30 minus, and this is a compound angle for sine that we're doing now. So you have to know that it is equal to sine cos, cos sine, sine cos, cos sine, sine cos, cos sine. Where are we? Jump gone over the place right here. So do an expansion and see which one of these is the answer, guys. Let me go back for the blue. So expanding the cos, the sine function. Sine cos, cos sine. Let me do it right here. So this will be equal to, all right, let me put it over here. So let me zoom up and put it over here. So this is going to be equal to sine cos, cos sine. That means sine 30 cos A. Since we have minus here, so they're going to get a minus here, so by expanding the sine compound angle. So whatever sine is in here, same thing come out here for the sine compound angle. For the cos compound angle, the sine is reversed. If you have a minus here, you get a plus out here for the cos one, and vice versa. So we have sine cos, one of the cos sine now. So it's cos 30 degrees sine A. See? Sine cos, cos sine. And these values stay in the same order. 30 then A, 30 then A. So all I have to remember is sine cos, cos sine for the expansion of the cos sine compound angle. Expansion of a cos compound angle is cos, cos, sine, sine. This one is sine, cos, cos, sine. Easy to remember. Don't need no formula sheet. And then now, you must know that the sine of 30 degrees is a half. So this becomes a half cos A minus, and the cos of 30 is root 3 over 2. Root 3 over 2 sine A. And based on these answers, we just need to look for the right one. And the right one is the first one, actually. So the first one is the answer, which is this. Nice and easy. First one. Done. All right. Compound angles. Let's continue. Make it a series of compound angle questions now. But not this one. This one is a solution. So the equation has only one real solution given by. So it's basically, how would you solve this? We can change the sign into cos squared, the sine squared into cos squared, because it's a cos, we can't change that. What we're going to use? We're going to use the fact that sine squared x is 1 minus cos squared x. That's what we have to use, Change the sine squared. So if 1 of this equals that, then 3 of this equals 3 of that. All right? So that's what we want to use. So this equation, let's write it now. This equation right here is going to become 3 of this, So it's 3 of this. So it becomes 3 minus 3 cos squared x equals 8 cos x. You get a quadratic in cos. I want my square term to be positive. I'm going to transpose everything over to that side. So when I carry this over there, it becomes a positive 3 cos squared x. The 8 cos is over there already, so I'm going to plus 8 cos x. And then this 3, when it goes over there, becomes negative 3. I would have equals 0 right there, so. But I'm going to put it over this side instead and erase this one. Same thing. Then I need to factorize this now. So factorize, these are prime numbers at the end. So it's easy when it's prime. So you go bracket, 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 bracket equals 0. Factors of 3 cos squared is 3 cos x, cos x. Now factors of the 3, but a middle term of 8. You put the 3 here, so you get 3, 3 is 9, and put the 1 here, so you get 1 here, so you get 9x, 1x, cos x, 1, 9 and 1. Difference is 8. All right, so that's why I put them there. Now, this says the two signs in the bracket are different. This means that the greater product must be positive. This is the greater product. We want it to be positive, so you put the plus right here and the minus there. Then you have the two factors, now you're ready to solve. So this one will give me cos x equals a third, but this one will give me cos x equals negative 3. This falls outside the allowable range. This is not valid because cos has to be between 0 and negative 1 as shown on the graphs. So this is not valid. This can't produce any solution. There's no angle for which the cos of x is 3 or even negative 3. So this is not valid. So the only solution is from that. Cos equals a third, and that is shown right here. They didn't ask us to solve it, I just want to know. So don't go solving it. So you have to look at your answers before you start to work. So your solution is right here. You get the solution from this. This is a different color. You get the solution from this one. That's it. Next one. Expansion of sine. This is very similar to one that we did earlier. The expansion of sine, and again, where was it? This one. Similar to, no, not that one. This one. This one. Just that instead of 30, 45, right? 45. But again, expansion of sine, let's do it right here, is sine cos, cos sine. Sine cos, cos sine. So this is going to become sine cos, cos sine. So it's going to become sine alpha cos 45 degrees. Since you have a plus here, you're going to get a plus outside here as well because you're expanding the sine component angle. So sine cos, cos sine. So it's cos alpha sine 45 degrees. Now the beauty about that, the sine of 45 and the cos of 45 is the same. Root 2 over 2 or 1 over root 2. And I'm saying 1 over root 2 because I'm seeing these answers with 1 over root 2. So this then becomes, this is 1 over root 2. So you get 1 over root 2. Let's write that better. 1 over root 2 sine alpha plus this also is 1 over root 2. So you get 1 over root 2 cos alpha. So you can factorize 1 over root 2 and you get sine alpha plus cos alpha. And those are my values. So you can put that one. A again. A. Answer is right up at A. You could have known from the beginning because when you expand the sine function with a plus in here, you couldn't get no negative and then three have negatives in there. So it had to be the one with everything positive. All right? So sometimes, the answer is right in front of us and, we're still going to work, but, that's what it is. That's that. Next one. Another one. This time is minus 45. You see? This was plus. We got the same thing, but this time now is minus. And all that will happen. Well, all of them giving us minus now. Right? So you have to work out and see which one it is. It's not the one with a half. But let's work it out. All right? Let's work it out. So again, it's the same approach. Expansion of sine is sine cos, cos sine. So let's go and do it over here. Sine cos, cos sine, right? So I'm going to get sine alpha cos 45 degrees because it's a minus in here. I'm going to put a minus out here. That's sine cos. I need cos sine now. Cos alpha sine 45 degrees. So it's sine cos, cos sine. And again, the angles in the same order. Alpha 45, alpha 45. All right? Then I'm ready now. The cos of 45 is root 2 over 2, but that 1 over root 2, so we can use it as well. There's 1 over root 2 times the sine of alpha minus, this is also 1 over root 2 times the cos of alpha. Then you factorize the 1 over root 2, you get sine of alpha minus cos of alpha. And that's what they're looking for. Sine minus cos. So the answer is A again. Sometimes, it's the same question and just change the values, but I don't even bother to change the answer that it is, because I think in each of these cases, the answer was A, right? Yeah, the similar ones, the answer is all A. All right, so let us change that. Another one here. Sine of x plus pi by 2, that must be minus. No, that must be sine is positive in the second quadrant. Right, so that must be minus cos of x. No, it can't be the cos of x. Because sine, this is in the second quadrant, x plus pi by 2 is in the second quadrant. It must equal the cos of x. As a positive, it's in the second quadrant where sine is positive. It must equal the cos of x, but you don't have to kill us. You can just work it out. Expand it out again. Sine cos, cos sine. Make it work out itself. Right, so it's going to become equal to sine x cos pi by 2 plus here, so plus here, so cos x sine pi by 2. So again, it's sine cos, cos sine. Sine cos, cos sine. No, the cos of pi by 2 is 0 and cos of 90 degrees is 0. So I know that this is 0 and this. Right? So this becomes sine x times 0. And but this is 1. Sine of pi by 2 is 1. This equals 1. Sine of 90 degrees is 1. It becomes cos x times 1. You put the times after x. It becomes sine x times, this is 0, plus cos x times this is 1. So you see, this become cos x, is gone. This is 0. This is what we're left with, cos x. So the answer is right here. We could know from the get-go. It has to be cos x, because this goes in the second quadrant because you're adding pi by it. And sine of an angle in the second quadrant is positive. So the answer is positive. That'll be positive cos x, because cos and sine have a phase difference of pi by 2. Once you add or subtract pi by 2, on the sine you get in the cos. That plus or minus pi by 2, on the cos you get in the sine. Just whether positive or negative. That's all. But that is it, guys. That is it. This over here was equal to 1. All right. Let's finish that. Let's continue. See, basically coming to an end now, guys. Coming to an end. So this one now to do. All right. Now, firstly, this is a complementary angle. So off the cuff, this right here is a cos of x. The sine of 90 minus x must be the cos of x. And then this now, this is in the second quadrant because it's x plus pi by 2, so it has to be negative. Because of the phase difference of 90 degrees, it's going to become negative sine of x. So this is negative sine of x, and this is cos x. So the answer is cos x minus sine x. See it here? Cos x minus sine x. But let's say I don't know that, right? Let's say I don't know that. I have to work it out. Well, this don't need no working out, because that must cos x. Sine of 90 minus x must be cos x. All right, so this already is cos x. You know, this is cos x. We don't have to waste time. So this one is cos x. What is this one? Let's work out this one under here. Let's see what it becomes. Let's work it out in red. It's cos, sine, sine. And since we have a plus right here, we're going to get a minus between them. Cos, sine, sine. So working out this one by itself. This one is already cos x, because the sine of 90 minus an angle is equal to the cos of the same angle. We know that. Complementary angles. Doing this one now. Cos, sine, sine. Together. Cos x, cos pi by 2. Since it's a plus, we're going to get a minus here. Sine x, sine pi by 2. What do we have here now? This is equal to 0. Cos of pi by 2 is equal to 0. And the sine of pi by 2 is equal to 1. So if we work it down, this becomes cos x times 0, cos x times 0, minus sine x times, this is 1 times 1. That's what we get. So you see, this is 0, and this is minus sine x. So it works out to be minus sine x. Let's put it back in blue now. It becomes minus sine x. Put it back in blue now. Minus sine x it becomes. So the answer is cos x minus sine x, which you could know from the get-go. This is the answer. Cos x minus sine x. But this part is cos x. And this part over here, so now leave it in red. This part over here, so now work out to be minus sine x. So one part is cos x, another part is minus sine x. So cos x minus sine x is the answer. Easy like that. Now come to this guy now. Compound angle for tan. All right, it's on a formula sheet. Let's go to just know them, right? So expanding this, right? So let's write out the compound angle for tan for you. It's on a formula sheet, you know. So it will be tan A plus tan B over 1 minus tan A tan B. That's a tan of A plus B, you know, equals that. Let's shift this over. And this is a A and this is a B. Right? That's what you're doing, right? So you're gonna get equals this thing up here. Let's work it out in red. This thing up here becomes equal to, let's work it out now, tan 2x plus tan pi by 4. And most of that tan of pi by 4 is 1, because the tan of 45 degrees is 1, over 1 minus tan 2x times the tan of pi by 4. Remember I said the tan of pi by 4 is 1, because that is 45 degrees. Tan of 45 degrees is 1. So it's going to become tan 2x plus 1 over 1 minus, and because this is 1, we're going to get tan 2x. I'm going to put it on it. That this is equal to 1, and this is equal to 1 as well. So you're looking for that one. This one is the answer. Here's that one. Right here. That is it. All right. That is that. Next question. We'll do this one already. This one already. We'll just use a calculator. That's a repeat question right here. We'll see it on the screen here. See there? Cos of 5 pi by 2. 5 pi by 12. I said it was this one. Root 6 minus root 2a and a quarter on the outside. This one is the answer. The calculator. We did it already, so we'll have to work out again. Remember, if they give you the cos of pi by 12, guys, cos of pi by 12, you can write as a cos of 3 pi by 12 minus 2 pi by 12. Then it's going to become the cos of pi by 4 minus pi by 6. Pi by 4 minus pi by 6. All right, remember that. They give you cos of pi by 12. So all they have to do. Remember that. All right, next one. I want this in radian. Now, when I give you an angle in radian, then I want it in degrees. All you have to do really is just replace the pi with 1/8. So all I have to do now, replace the pi with 1/8, because remember the pi is equivalent to 180 degrees. So you don't have to do no gymnastics. Once it's given in terms of pi, just replace the pi with 1/8. So that angle that I want now, let's zoom it up right here. Let me mark it. This angle right here, work it out over here, becomes 4 times 180 degrees divided by 5. That's what you're working out, you know. 4 times 180 over 5. Which answer is that? Yeah, I'm gonna burst my brain now. I can't sit down, simplify it down. Boom, boom, boom. That's 144. So it's 144 degrees right here. And the practical give the same thing, you know. Just that instead of 4 pi, they give 8 pi. So you know it's gonna be twice as much. So the answer right now is this, you know. Twice as much, 288. It's the same position. But to show the working, it's the same thing. Just replace the pi with 180. So you get 8 times 180 degrees divided by 5. You're gonna get this as the answer for sure, because it's twice as much as that up there. All right, are we coming to an end? Yes, we can fast. We did these questions already yesterday, and we have a couple more tricks question right here. This one, want to tan off 150. Drop it in the calculator. That's a negative angle. It's negative. This one is the answer. Tan off 150. I think they gave one where they get sin of 150 over the cos of 150. So it's really the same question, but this time just give a tan, because it's equal tan. We can drop that in the calculator and get it, right? It's the same. You see this? It's the same as, because in the second quadrant, it's the same as minus tan of 30 degrees. Tan of 30 degrees is 1 over root 3 minus tan of 30 degrees, which becomes the negative 1 over root 3 right here. All right. And the second quadrant, 150 is equivalent to 180 minus 30. This one now, it says this is equal to 4 by 3. What is tan 2 theta? All right. So tan 2 theta using the double angle formula for tan. This is the same as 2 tan theta over 1 minus tan squared theta. When you know these identities in the head, it's very easy, right? You don't have to stop to think. And the tan theta is 4 over 3. So it becomes 2 times 4 over 3 over 1 minus 4 over 3 squared. And I can just put that in the calculator again. Why waste time? Just drop that in the calculator because you have it there, you can use it. Let me shift all of this down. I'm too close to that one. Alright, so I'm gonna drop it in the calculator now. So I'm gonna get a fraction, 2 bracket, 4 over 3, close bracket, not there. Close that bracket over 1 minus, you can put that as 16 over 9. Instead of 4 over 3 squared, I must write 16 over 9. And I get that answer, and I'm going to look for it as a fraction, and it is negative 24 over 7, which is right here. Good? Simple as that. Soft. With a capital T. This question now, testing your knowledge of a double angle for cos. Double angle for cos. This one. They give it in terms of sine. Sine x equals s. So you're going to want this in terms of the sine because they want to give that in terms of the cos. Let's try the three things it equal to. It is equal to cos squared x minus sine squared x. That's the first thing. Or it is equal to 2 cos squared x minus 1. Or it is equal to 1 minus 2 sine squared x. And clearly, this is the one that we're going to use. Why are we using that? Because they told us that sine x is that. And so the answer is going to be 1 minus 2s squared. So the answer is right here. So if they are giving you, for example, cos x equals c, then you would naturally use this one. 2 cos squared minus 1. That will be 2c squared minus 1. Right? So they could give you that. Instead of sine x, they could give you a cos x. You have to use that one. But you have to know these identities, guys. When you know the identities, questions are just so easy. All right. So that is that. This one now, this trig expression I want to write as a single fraction. I want to make the two denominators the same. Bam, bam. And I must recognize this as part of the difference of 2 squares. So what am I going to do? Let's zoom up. I'm going to write back each of them, but I'm going to multiply this one, numerator and denominator, with this denominator. I want this to become the difference of 2 squares. I want this also to become the difference of 2 squares. The two denominators must be the same. So I'm going to write about the sine x. Zoom it up. So I'm going to write about the sine x over 1 minus cos x. That's the first fraction, right? First fraction. I'm going to multiply that one with 1 plus cos x. 1 plus cos x over 1 plus cos x. So it means that this and this, they will become the difference of 2 squares. Right? And then the second one was a plus this one, which was sine x over 1 plus cos x. So this one now, I need a 1 minus sin x on it, right? I'm going to multiply this one now with 1 minus cos x and 1 minus cos x. So like I'm multiplying by 1. And then the denominators all become the same, right? The denominators all become the same. They become the difference of 2 squares. So I can work the numerator now. So this numerator firstly becomes sin x plus sin x cos x. Let me shift that over. And then this denominator, and I'm adding, right? Becomes plus another sin x times 1. And then subtract the sin x cos x, subtract this time, subtract. So I'm subtracting sin x cos x. And all of that is over the difference of 2 squares. Now, the difference of 2 squares, when I expand it out, these two, it will become 1 minus cos squared x. Because it becomes 1 squared minus cos squared x. I'm going to take out the square and the 1. Then now, if I consolidate the values on the numerator, this one wipes out this one because they have opposite signs. So I'm just left with 2 sin x on the numerator, 2 sin x. So it becomes 2 sin x over. Then now, this 1 minus cos squared is actually sin squared x. And then one of these sign cancel with these, and so it reduces to 2 over sin x. And then says right here, 2 over sin x. That is that. And we are done. What time is it? We are done at 3 o'clock with an hour to go. So I think we can just take a 8 minutes break, and then I'm gonna bring up the specimen paper and we'll come back and spend maybe 10 minutes, 15 minutes just to run through. Because what happened, remember, you know, on the advanced specimen paper, you're not gonna find a lot of questions on statistics, multiple choice, and motion and straight line multiple choice, right? So a couple that they set on a specimen paper, we have to make sure we understand and can do them, because CSEC will set questions that are very similar and sometimes almost the same as appear on the specimen paper. So I'm going to take a look at break. I'm going to search for the specimen paper. It's in the syllabus, right? It's in the ADMAT syllabus, and we can look at the statistics questions and the motion and straight line questions. Short break. I think I finished all the questions in this document in the 2 sessions. Everything finishes on this. And guys, believe me, if you go back through these, and you're gonna have a sweet time in that exam room if you understand all these questions and know how to work them, right? You're gonna have a really, really fun time, I promise you. Without a shadow of a doubt. I'm telling you. Because there's not many different ways they can set questions around these topics. All right? I we left out here were the functions questions, which functions not on the syllabus. When I bring up a specimen paper, I say, but we left out the functions. I don't think we get any of these. Any questions similar to these functions, all right? We replace the functions questions with the motion and straight line and the statistics. That's how we keep the 45 questions. We took those out. Because the functions question at ADMAS, they are too similar to the CSEC functions. They're almost the same level of work. Right? And then what they do now, you pick up back functions and pyramids. They don't bother with it at CSEC anymore, at ADMAS anymore. All right, so let me bring up the clock. I'm going to take a short break. And I remember I said we're going up to 4 o'clock Jamaica time. And it's 3 o'clock now. So take a short break. And we'll take just in a short time, just go through those questions. So let me bring up the clock, and I'll let us look at the specimen paper to just run through those motion and straight line questions. All right. So let me start the time. 10 minutes. 10 minutes. Might come back before 10 minutes. 10 minutes. 10 minutes. 10 minutes. I'll find the paper. Specimen. So this is done. That's paper 2. Paper 1 should do for it. Right. Yeah. Motion straight line. Mark the ones that we're gonna solution done already. Okay. This is before here. Doesn't look that way. All right, guys, let's just finish this quickly. There's a few questions on the specimen paper. All right, when I'm finished, what I'll do, I just I will scroll through a bit, just for the purpose of the video. The process can basically get a look at the questions and the answers that are there and some of the solutions. But the questions I'm particularly interested in right now are the motion and straight line questions. I'm talking about 2 of them, and the statistics question, maybe 3 or 4 of them. This first one is at number 35. I'm going to leave the answer marked and let's explain the solution, right? Number 35. So they give this question here, number 35, and what they said here is that an object moving a straight line with a velocity given by this. That's a velocity formula. And they want an expression for the acceleration. Now remember, the hierarchy of the motion a straight line with respect to how you go from components of motion. Displacement, you differentiate displacement to get the velocity. You differentiate velocity to get to acceleration. So you go up the hierarchy here by differentiating. And if you want to go from acceleration back down to velocity, and velocity down to displacement, then you do the reverse process, which is integration. You integrate. Make it look smaller. All right, so you're going to integrate. All right, so since you have velocity and you want acceleration, then we're on this leg. We're this way. You have to differentiate. So the acceleration is the rate of change of the velocity, dv by dt. So we're differentiating this. But these twos are multiplying constants, so it's not going to change. So you're going to put back the 2. You differentiate what's in the bracket. So differentiating the t squared, you're going to get 2t. Differentiating the minus 6t, you're going to get minus 6. Then if you expand this, you're going to get 4t minus 12. Hence, this is the answer up here, 4t minus 12. All right, so remember, that is the hierarchy. All right, so the next question we want to look at, I think, is another motion in a straight line question. Another motion in a straight line question. Let's finish this quickly because sanitization team is here now. All right. So for this one, no, they give us the velocity here again. They said velocity d meters per second of a particle starting from rest, and this starting from rest is very important. Starting to move from rest. It means that when t equals 0, the velocity is 0. That's what normally means, but that's not the case here, no, because when t equals 0, right, you're gonna get a velocity of 3. So I don't know why this is moving from rest. Don't make any sense. It says move a particle, move from rest. And that is not the case. But it doesn't mean that move from rest, but t is not 0. Because right now when t equals 0, the velocity is 3 based on this, right? So sometimes the right statement and I give you a formula which is not consistent. All right. Then it says no, the displacement when t equals 3. So to get the displacement, same thing we did a while ago. So we have the velocity, and you want to go back down to the displacement, you have to integrate. You have to integrate. All right. So this time we have to integrate the velocity. So that's what I'm doing right here. So I'm going to start it over and show it again. So you're gonna get an expression for the velocity for the arm. I think the start from rest particle straight line from rest given by that. So we're gonna assume that we're gonna have to assume that when it starts, the displacement is 0. All right, start from rest. The question is not constructed properly because they should have given us some indicator as to how to find the constant of integration. All right, so but for the purpose of the question, the displacement is the integral of the velocity with respect to time. And so we're integrating the 6t squared minus the 4t plus the 3 with respect to time. Let me erase this. All right, so it becomes equal to, add 1 to this power, get 6t cubed over the new power of 3 minus 4t squared over the new power of 2 plus 3t. And now we're supposed to have a plus c. Because them say it start from rest and they don't give us any indication of where it started from, we have to assume that when t equals 0, the displacement was 0. So when I say when t equals 0, the displacement is 0, so assuming it starts from the reference point, and therefore based on this equation right here, the c equals 0. So this t is equal to 0. And then we're trying to work on what's the displacement when t equals 3. When t equals 3. So when t equals 3, what is the s? Well, this right now is 2t, 2t cubed. So I'm just going to write 2 times 3 cubed minus, this right here is 2t squared. And so I'm going to write 2 times 3 squared plus 3 times 3. This is 0, right? Remember, this is 0. So I'm not putting it back. And then just work this out. If I draw for the calculator quick, I can just work it out on here. These are small numbers to work with. So this becomes, this is 27. 27 times 2 is 54. Minus, this is 9. 9 times 2 is 18. And you're adding back a 9 right here. So really, this is negative 9. So 54 minus 9 is 45. So the answer here is 45. That's why this is the answer here. That is shaded and that is marked 45. All right, that is that. Then we'll come to the next question down here, which is a statistics question. And it gave us this box and whisker plot. Right? It was this box and whisker plot. And it says the shape of the distribution of the population. And said the refers to a box and whisker. The shape of the distribution of the population. Now you can clearly see that this box on the left is longer than the one on the right. Right? The two whiskers are around the same size. So this is a negative skew, but the left box is longer, right? So it's negatively skewed. So this is the correct answer. 3 only, and that's why this is the answer that is marked. It's negatively skewed because the box on the left is longer. Right? That's a longer box, so it's negatively skewed. All right. Then we'll come to this one now. But this one says, let me erase this. Right. This is just an analysis of something. It says the probability of an event A occurring is 0.3. So basically saying that the probability of A is 0.3. It says, and the probability of an event B occurring is 0.6. So the probability of B is 0.6. That's the information given. It says, given that the two events are independent, what is this? Now, the two events are independent, right? Then it means that independent events, for independent events, this. Put it in red. For independent events, two possibilities happen. The probability of A, given that B has occurred, will be equal to the probability of A still. That's 1. Or the probability of A and B occurring will be equal to the probability of A times the probability of B. That's what happens when events are independent. And they're asking us for this. So this one will apply. Because they are independent, for the question, we are applying this one. So the probability of A, given that B has occurred, is equal to the probability of A, which is the same 0.3, because they are independent events. And so that's why this is the answer, 0.3. Right? That is that. We mark this in red to show that this is the one that we're using to solve the question. So these are the two possible things, two things you can consider for questions that involves independent events. All right, this one and that one. All right. The next question on this paper, we can look out for questions similar to these guys, right? Is this one. This one is a mutually exclusive question about events being mutually exclusive. It says two events C and D are mutually exclusive, right? So if they are mutually exclusive, it means that if you should draw a Venn diagram for the two events like this, then you'll have two separate circles, no intersection. Two separate circles, or two separate subsets, no intersection. And this will be a C, this will be a D. C and D. Right? Probability of C is 0.2. So you put in 0.2 in here if you show the probability on the Venn diagram, right? And you put the 0.2 inside here. And the probability of D will be 0.3. You put the 0.3 inside here. The probability of the union is 0.5. That is true. Right? Now, the probability of the union is already 0.5, right? And you are already accounting for the A and the D, the C and the D. It means that there's no intersection, right? So this is the intersection. It must be 0. Right? There's no intersection. So when they are mutually exclusive, there's no intersection, none. So the probability of C intersect D, because there is none, is equal to 0. And that's what happens on mutually exclusive event, and that's why that is the answer. Right? They are already accounted, everything is already accounted for. There's nothing in the intersection. They are mutually exclusive events. All right? All that will happen in this Venn diagram is that you'll have another 0.5 outside of A and B, because the total probability must be universal set must be 1. Right? In the universal set, total probability has to be 1. 1. Total must be 1. Right? If you were to show it like that in the universal set. So it means that the probability of not getting A or B, none of them is 0.5. Union is 0.5, so the rest of the universal set must be 0.5. But there's nothing in the intersection, guys, simply because they are mutually exclusive. So even without all of this information, you could know that the answer is this. Once they are mutually exclusive, the intersection is 0. So for mutually exclusive events, the intersection is 0. So we can actually just write that almost like a theory. For mutually exclusive events, the probability of A intersect B is equal to 0. There's no intersection. That's a given. All right. This one now. And sometimes some of these questions you can draw a Venn diagram to represent what you want to show and represent the information. This question says, in a class of 50 students, once you start to hear that, it's supposed to start thinking Venn diagram. Right? The Venn diagram can show the information. In a class of 50 students, 20 study chemistry. I'm going to draw the Venn diagram so we can see what is happening. All right, so Venn diagram of 50 students. And maybe this first, shift this up. Right, so chemistry and physics. This is chemistry, this is physics. All right, so there are 15 universal set. That's right, those. All right, 50 in overall, 50. And in chemistry, there are 20. So everything in chemistry must add up to 20. Here and here must add up to 20. Right? And 25 in physics. I'm going to put it 25 right here. So here and here must add up to 25. And they said there are 10 in both. So that we have 10 in intersection. So if here and here must add up to 25, it means that right here is 50. They must add up to 25. Similarly, these two subsets must add up to 20. So here must be 10. So far we have accounted for 35. So it means that total must be 15. So it must be that you have 15 not doing chemistry or physics. It says the probability of a student who study neither. Talking about these, neither. These are the neither ones. Neither physics nor chemistry. So this is the number for neither. 15. Neither. The neither is referring to these. You want one of those out of the 50. So that is probability of neither. Let's call it n. Neither is set n. Probability of n, neither, is 15 out of the 50 students. So the answer is A. That's it. The Venn diagram shows up everything. All right. Can also be done by calculation, but the Venn diagram is a nice tool to use to show the data and all information to make it clear. All right. That is that. And I think that's it for the 5. All right, so let me just do a little scroll down for the purpose of the video. Oh man, let me undo and redo. Right, let me just do a little scroll down for the purpose of the video of this specimen paper. Let's do a slow scroll down so persons can see the questions and look at the solutions that are there. I'm not going to work them out. Those are the questions. Can pause and look at the questions and so on for additional practice. But I find that CSEC tend to set questions on their exam papers that are very similar to what they set on their specimen paper. We see that in the paper 2 all the time. And so we can expect the same thing on the paper once. Right? Questions are very similar. So just doing a nice, like a slow scroll down for the purpose of the video, but the solutions are here. We did work through this paper already in my regular class. So you can pause and look at the questions and look at the answers and solutions. All right. Just slowly scrolling down. I think this question is similar, let me see. Maybe first term. Okay. Not the same. All right, let's continue down. And then we come to here. Let me erase this. All right. So I'm going to end the session after this, guys. So I'm scrolling this down for the purpose of the video. So those who want to have a look at these additional questions. I think for this one, it's similar to the one that we did a while ago, where we add up and make the denominator the same. Like I multiply this one with this denominator, numerator and denominator, multiply this one with this denominator. And then I come out with that, right? I make it one fraction, works out to that. So I think we did this question on a blank page. That's why I'm not seeing the working out here. That's the answer. This one I think we did on a blank page again as well. Let's expand it out. Sine, cos, sine, and come on to that. Sine, cos, sine. We do this question similar to this a while ago. Just that they are a plus right here on the question that we did. This one is a minus. All right. This one is cos 2a, a plus a, which is equal to that. So these questions are very similar to some of what we've done today. So another one here. We did one with tan, but this one that we did a minus right here. Instead of a plus, this one right here, we did a minus. So you see the similarity with these questions as well. We did one like this. This time we have to change this cost to 1 minus sine squared. Because this is 2, it becomes 2 minus 2 sine squared. Let's write it properly. 2 minus 2 sine squared x. That's what we use, right? And then we get a quadratic and solve out get that. That's the answer. So you can try that. Get a quadratic in sine. So somebody may not see the working note because we did do some of the working note on a separate page, right? So that is it. We're not seeing some of the working note. But these are the correct answers that are there. Okay. So this 35. I'm up to the end now. So let me erase this. Oh, I didn't do this question yet. Skip over this one. Wow. I didn't do this one right here. I didn't do this one now. Skipped over this one. This is also a statistic. I didn't do this one. All right, so let me erase this. So what it is that they give us this data. Table now shows the number of children Hold on a second, guys. Right. So this one shows the number of children. Table, the number of children in a family is shown table below. So what it is that there are 9 families with no children. There are 10 families with 1 child each. There are 12 families with 2 children, so that's 24 children total. There are 7 families with 3 children each, that's 21 children. And there are 2 families with 4 children, so there are 8 children there. And the question wants us to calculate the mean number of children per family. So what we calculate this number of children per family. So you want to calculate the total children over the total family to get the mean number of children per family. Total over total family. That's what you want. Total number of children over the total family. So if you to get the total number of children, you have to multiply these. So 9 times 0 is 0. Then 10 times 1, 10 families at 1 each, so that's 10. Then 12 times 2, that's 24. It's 24. Then let's zoom it up. Make this better. Then 7 times 3. 7 families has 3 children each, 7 is 21. And then 2 families had 4 children each. That's 8 more children. That represents the total number of children. Then it's to add up the families now. How many families are there? Number of families is some of these. There are 9 families. 9 plus 10 plus 12 plus 7 plus 2. That's the total number of families. And so we're doing this calculation, guys, to get the total number of children over the total number of families. This is 0 plus 10. And let's get a calculator and work this out quick. Let's work it out quickly. And we should get that answer you're seeing on the screen. All right, so the fraction on the numerator we have 0 plus 10 plus 24 plus 21 plus 8 over 9 plus 10 plus 12 plus 7 plus 2. 1.575 right there. That's how we get that answer. Total children over total family. Because they want the mean number of children per family. So because they want it per family, you need total children over the total family. All right, that is that. Let's go back to the scrolling. So I've gotten up to here, I think. And yeah, scrolling. Next page, and we should be done. Right there. End of test. Bang. All right, guys, that's it now. Hope you get a chance to look back over. I know you have a lot of exams back to back this week. Hope you get a chance to look back over, watch the videos again, look back at the questions. You really want to get 45, what a 45 in the multiple choice exam. All right, so, but that is it. I'll be here. My students will do some more work prior to the exam. All right, so if you have any questions and so on, you can send it to me still. And you can share the video that's online. Process can really benefit from it. All right, and the good thing is that it is in section, so you can share it and let persons can benefit from it. All right, but that is it, guys. I'm gonna end it now. Have a great rest of day, and I put in the work for your other exams, not just about advanced alone. Okay, everybody.
Yes, sir.
All right. Bye bye. Bye, everybody.